Whoops, I think that's the wrong screen. Hold on. There, do you see the full slide now?
Yeah, perfect.
Okay. And this should be finished, including questions, in 45 minutes, right?
Yes. Right. So, but actually,
Atik bhai, we have 1 hour for him.
Yeah.
I mean, Matthew can, give a talk. Let's say 45 minutes and 15 minutes question answer.
Yeah, and if you need, you can extend it like 50 minutes, no problem. Because Professor Shamim, there is this the next session will start at 10. Yeah. So.
Okay. Well, I'll try to keep on time, but that's good to know.
Yeah. I mean, if we need a QA session longer, I mean, we'll just continue. No problem. Is it all right, Professor Shamim? Because basically, after the next session, I mean, after you, the next session will start at 10 in Bangladesh. So it means that 90 minutes from the beginning. So anyway, so
okay.
Someone is recording.
I'm sure people want their break also, though.
Yes. So Anirban is here. Dr. Anirban Bandyopadhyay. He's not here. So on that case, let me start the talk. All right. So Professor Shamim, may I start? Like the live is okay?
Just a minute, please.
Okay.
James. Good morning, everyone. On behalf of IC4IR, I would like to welcome all of you to this, keynote session. This is the first event of the day, and we have Professor Matthew Turk as a keynote speaker in this session, and Professor Atik Ahad will be the session chair. So let me introduce Professor Atik Ahad. Professor Ahad is a senior member of IEEE, senior member of OSA, and professor of University of Dhaka, currently a specially appointed associate professor of Osaka University. He authored 10 books in Springer, published 180 peer-reviewed journal. His research interest includes machine learning, computer vision, data science, sensor, and healthcare. Now, without further ado, I will turn the time over to Professor Ahad.
Yes, thank you very much, Professor Shamim Kaiser. We have a extremely distinguished Professor Matthew Turk. Many of you know him by this time, especially in Bangladesh, because he was the, he is the founder, the general chair of ICIEV conference, which we started at the University of Dhaka, Bangladesh, and we are extremely grateful to him because, he's such a big guy and still, was with us and is still with us for this path. So ICIEV. With him we started, and we thank him very much. He visited Bangladesh once in ICCIT at Daffodil International University, Bangladesh, and also some of you met him in Japan when ICIV was held in Kitakyushu once. But I can see Dr. Sadia here. She was a student, but now she's a PhD and professor. Professor Matthew Turk served in top forums like the #1 conference on computer vision and pattern recognition. So he was a general chair once, and automatic face and gesture recognition, where I met him basically in Santa Barbara 11-12 years before. And then we become connected until now. We are very, very friend. I am grateful to him for his guidance and support for the year. And he's an IEEE fellow, as well as the fellow of International Association of Pattern Recognition. One thing is that, I mean, his Google Scholar citation is 43,000, but this not the number is one side. But most important thing is that if you work on recognition or eigenface or this kind of things, you know his work, that eigenface for recognition, for face recognition, and so on. And those work during his PhD, I mean, just his PhD work has been cited. I counted, it's like, I mean, almost 29,000 times. So it means that what a contributing original idea he produced during his PhD time. And since then, he has been serving in different forums. And finally, he's with the Toyota Technological Institute at Chicago. Don't think that it's in Japan. And he's the president of TTIC. So I think, I mean, I don't need to add further. With just the only thing is that we are co-editing a book on computer vision and applications, the future challenges, together with Richard Hartley from ANU and Dr. Rupal Mahbub from Qualcomm. So I hope that we'll keep in touch, and we would like to have Matthew Turk in Bangladesh in the future. So I would like to request Matthew to start your talk. Take your time as long as you want. No problem. We have, I mean, a window. Thank you so much.
Great, thank you. Thank you for the introduction, and I'm really happy to be here. I feel like I have a good and special connection to Bangladesh. For several years now. As you said, I have visited once, and hopefully I'll visit again. So I'm really grateful to be speaking to you all today. As Professor Ahad said, I did some work in face recognition long ago. I haven't done a lot of work in face recognition in recent years, but I've actually become much more interested in sort of societal issues related to this topic. So my goal in this talk here is really not to talk about detailed technical things, but to talk kind of broadly about this public discussion related to AI in general and face recognition technologies in particular. So beyond just the technical issues, there aren't going to be any equations or math or experiments in this talk. And I'm going to run through a lot of slides quickly to try to just give you a sense of several different things. But I'm really kind of focused in things including bias and fairness in AI and machine learning and face recognition, but then also beyond those things, specifically how they connect to other scholarly studies and other things like government and ethics and such. And much of what I'm going to say is probably US focused in many ways, at least in terms of the details, but I think it all translates very well to things that are going on throughout the world. So let me start in this topic of beyond bias and fairness in face recognition with a few examples of the kinds of things that we're seeing very frequently lately. So here are just a few examples. On the top left here, a piece in the New York Times not too long ago talking about the racist history behind facial recognition. And then you see other pictures here from demonstrations that are basically anti-face recognition technology, and something down on the left about stopping face recognition use on college campuses. And these are just a very small sample of a few things. Discussion about face recognition technologies is everywhere today, in the media, among privacy advocates, civil libertarian circles, legislative bodies at all different levels, scholars in the arts and humanities and social sciences, and of course, researchers and engineers in technical areas. But it's really hard to turn on the news or open a newspaper these days, or especially go to like an AI conference without seeing something about the dangers of AI or specifically face recognition technologies. And so it sort of seems like the key question these days is this next slide, the blue circle here. Who thought it was a good idea to have face recognition technology? I mean, in a sense, there's so much energy and discussion about dangers and negatives that it's kind of worth stopping and like this report from the Brookings Institution asked, why do this in the first place? You know, what got people interested in it historically and more recently? I have worked in face recognition on and off for over 30 years. 30 plus years ago when I started doing it, I thought it was a pretty good idea. I thought there could be some really interesting applications of it. And in fact, I still do. And so let's start with that. Let's start with, just to be clear, some of the positive motivations for automatic face recognition. So here are just some examples of useful applications, things like secure access to buildings and locations, transaction security, organizing photos, unlocking your cell phone, border security, aids for visually impaired, and lots of things of various size, you know, little things, medium-sized things, and even some very large things. And here's an example of something that I would call very large in terms of significance. People have used face recognition technologies to reunite missing and trafficked children with their families, to be able to locate, identify children who have been taken and lost. And here's an example of this being used in New Delhi a year or two ago, and identifying thousands of missing children in just days. And there are other examples like this around the world. There's also lots of use of face recognition technologies, or interest in use in law enforcement agencies to try to find criminals and to help solve situations regarding terrorism, murder, kidnapping, child abuse, sex trafficking, battery theft, and other sorts of things. Many terrorists and criminals and persons of interest have been found using Interpol's facial recognition system by a few years ago, and many more by today. And also, importantly, to think about, face recognition is not just used in these scenarios to sort of catch the bad guys, but also to actually clear suspects who are not the bad guys, people who might have been detained or are suspects or something, to be able to say with some high degree of certainty, actually, they're not a suspect. So let's not disrupt their lives and such. So there are both good and bad things going on, but there is a lot of positive. And I started with a New York Times article in the last slide, but here's a New York Times, or just a screenshot of a New York Times opinion piece a couple of years ago from the former New York City police commissioner, who is saying, from his perspective as someone who's very much in the thick of lots of kinds of investigations, how a technology like facial recognition can really improve things, can really make things safer for citizens. So it's interesting, I think, to balance a lot of the things we hear nowadays with negative views of facial recognition, which I think are important, and I'll talk about those, but also with the positives and with the opportunities. So given that, we can go back to this question again of why do automatic face recognition? And again, there are lots of different answers to that, all kinds of applications and utility for it, from very small things to larger things, and again, police departments and things like that. So I think there's a lot of potential value. I'd like to go back to 30 plus years ago, when researchers first started thinking about some of these questions. Why did we at the time think a lot about face recognition? I think it would be a worth thing to do. A lot of it was, frankly, curiosity. That years ago, people working in AI and computer vision thought, well, recognizing faces would be a challenging problem. And that seems to be something that humans do, and maybe other biological systems do. Maybe it's important in a sense to vision in general. And it's certainly a good example of object recognition. So just in general curiosity, scientific curiosity, people started working on computer vision based facial recognition, along sometimes with colleagues doing human vision, doing neuroscience, and in some cases, just to kind of address the question where people would say, well, computers might be able to play chess, but they can't do X. They can't do other human-like things like recognize a face. So people, in the very early days took that as a challenge and said, well, maybe they can, and let's actually try it. And so people tried lots of different ways in the early years to do face recognition. Research in terms of 2D oriented, very early work. This slide here, this picture here is from Takeo Kanade's work in the early 1970s, which is one of the earliest, most influential works, but then other works as well. So a lot of different approaches over the years. And then companies began to say, well, we should be able to commercialize this. There's probably a need for it. There seems to be progress. So let's try to commercialize it. And basically for a long time, and particularly in the early to mid to late 1990s, there are a number of companies beginning to commercialize face recognition, hoping for markets to emerge in this technology, thinking that there would be markets in security, building access, things like that. But it was really a tough time. The technology wasn't really that good, and the market really wasn't big enough. So it was a bit of a struggling time for that field. But then something happened pretty soon after that changed things a lot. And that was the terrorist attacks of September 11, 2001. This really brought new urgency from the federal government in the US and many other places to looking at technologies like automatic facial recognition in order to help with border security and such things. So funding increased significantly after this event. And other sorts of applications for face recognition followed suit. So for more local surveillance and security, for police departments, for casinos, for check cashing machines, all kinds of things. So this actually pushed the need and the desire and the funding for both research and development in face recognition pretty significantly. And then some years later, there was another event in the US that was, I think, also quite significant in continuing to push this forward. And this was a bombing that took place in the Boston Marathon in 2013, so about 8 years ago, which killed some people and wounded many people. And this was a situation where face recognition actually could have been of significant use. And this was actually shown in a study by researchers at Michigan State after the fact. And they showed how current face recognition systems at the time could have actually done a good job in helping to figure out and find these suspects here. So this was just another thing that helped push the desire and the need and very much the funding sources in the US for this technology. And then time went on, and over the years, there's been a lot of progress. So as I suspect that many of you know, particularly over the past, about 7 years or so, when the deep learning phenomenon has really pushed things forward in artificial intelligence very much, face recognition has advanced a lot. So old techniques are not used so much, and things like this Facebook's deep net for face recognition, things like that are the state of the art and doing quite well in a lot of cases. So in addition to people doing research and development and building applications of face recognition, there have been other directions of interest quite different from this. People in non-technical subjects. So people studying science policy, various humanities subjects, people studying ethics. Actually, for quite a while, there's been a lot of overlap between these scholarly interests and new technologies coming around. So things like nuclear weapons, chemical weapons, cloning, stem cells, things like that. And a lot of this over the years has at least hinted at AI kinds of technologies. And in recent years, a lot has been discussed by these scholars in these various areas about face recognition technologies. And these questions always come up in these sorts of discussions with people from humanities and sort of different society viewpoints. What are the responsibilities of individuals, of companies, of governments, of society in general when these technologies come about, and both for good and for potential bad? So it's really interesting, I think, to have these discussions, these sort of interdisciplinary discussions with both people thinking about the technologies and people thinking about other aspects of them and societal implications and such. One of the very well-known examples of this is the book 1984 by George Orwell, which came out many, many decades ago. And this book is constantly brought up in people who talk about ethics of AI and of face recognition as sort of a comparison to the present day situation, or the concern to where we might be going with these technologies. And there's a significant concern or fear of this Orwellian dystopia of mass surveillance and a sense, very powerful governments taking advantage of their citizenry with these sorts of things. And also, these discussions don't just take place in a vacuum. They're also informed by other things going on in society. And the general environment of these other things includes these many kinds of data breaches and other sort of ethical issues and debates we've been having for years now, related to security and privacy of data, related to unemployment due to technology, related to inequality that sometimes technology seems to broaden, bad or hazardous online behavior like bullying, all kinds of things that, not just face recognition, but technologies over the years have brought up lots of issues that have concerned, people for various reasons. So it's a general environment where there's sort of an increasing amount of distrust or perhaps a declining trust around the world and around technology sectors even. Distrust in government, police, news media, and other institutions, and of course the technologies themselves. So it's just an interesting place that we are in, and this is just the context of these face recognition discussions. So now let me jump back into face recognition in particular. There have, of course, been a number of really specific things in recent years pointing to problems, errors, bias, things like that in face recognition systems. I want to just kind of quickly run through some of them. I won't go through all of these, but I'll mention a few of these, of the many sort of well-known publicly things that have come about in recent years. So for example, this first one, about 6 years ago, there was this flaw in Google Photos that turned out to be very embarrassing and very kind of bad, where they labeled photos of some Black people as gorillas. A very bad thing, obviously, for a company to do. And it was of course a mistake, but it sort of pointed out what kinds of effects there can be, even in not that important applications. It's not a high security thing, but it's something that lots of people see and can certainly have various implications to make this kind of bad mistake. Also, several years ago, there was a company called Faceception that claimed to score facial images using personality types like academic researcher, brand promoter, terrorist, pedophile, to be able to sort of predict behaviors based on just facial images. And there was a lot of uproar about, that someone even doing that or claiming that it could be done successfully, or even wanting to apply that kind of thing. In 2018 was the now famous Gender Shades paper that came from a group at MIT showing disparate performance in commercial face recognition systems across classes of gender and skin color. And that was really important in terms of letting a lot of people know, especially in the general public who hadn't thought about this much, that there's some pretty significant issues in bias in these sorts of systems, and maybe in other kinds of AI systems as well. let's see. So there are several other things. I'll mention the ACLU used Amazon's facial recognition system in 2018 to do a test where there are lots of errors and kind of embarrassing errors where members of the US Congress were incorrectly matched with people in an arrest database. Let's see what else. There have been accounts of a few specific accounts of people in the US, African-American people in the US, being wrongfully arrested, where facial recognition systems were used, at least at some point, in the process of wrongfully arresting these individuals. And that's a pretty big deal, to actually arrest somebody, throw them behind bars, whether it's for a short period or longer. And these have generate a lot of concern and interest. These are the three men in particular, and I think it's actually quite important to think about the individuals in situations like this, what they went through, and the effect of these kinds of technologies, that they could be doing this kind of thing to lots of people unfairly and in quite disparate ways. We can talk about sort of the numbers and what's the good they do as well as what's the bad they do, but I do think it's important to acknowledge these kinds of significant problems. Other studies that have claimed to correctly classify things like political orientation from face images, Uber drivers claiming that the companies being racist against them based on facial recognition software. Recently, Facebook having to apologize after another bad labeling problem with their images. So a bunch of things. And then also along with these sort of specific incidents over the recent years, a number of data sets and face recognition systems have been decommissioned recently because of these serious concerns that have been raised. So for example, Amazon, Microsoft, and IBM have all announced pauses or halts on their development or their marketing of face recognition technologies. New York lawmakers have passed a moratorium on the use of certain face recognition in schools. UK Court of Appeals has halted use of a system. Down at the bottom here are 5 widely used face recognition related databases that have been taken out of commission now over these sorts of concerns. Let's see, some other company action. So in early 2019, Google said they wouldn't sell their face recognition technology, at least for a while, under certain circumstances. Again, IBM, Microsoft, and Amazon have all made significant changes. And then most recently, just about a month ago, Facebook announced that it's shutting down its face recognition system and deleting billions of face recognition images or signatures as part of a company-wide movement to limit the use of these sorts of technologies in their products. So a lot of interesting company actions following a lot of this sort of public discussion and to some degree outrage about face recognition technologies. An important thing to think about here, though, these companies like IBM, Microsoft, Facebook, Amazon, they have made a lot of public announcements, gotten a lot of press about these, but in fact, they're not the companies that really are used mostly in most of the deployed facial recognition systems. It's really mostly companies that you may have heard about, like NEC, you would probably know about, but a lot of these you might not even have heard of. And these are companies that are really doing most of the heavy lifting in terms of implementing real working face recognition systems in various contexts. So Microsoft, IBM, Amazon, Facebook, they might be getting good PR at little damage of not using these things, not selling these things. These are the companies that really make a difference, but we haven't heard those kind of announcements from these companies, which is interesting. Another interesting situation is this company that you may have heard of, Clearview AI. Clearview AI a couple of years ago was sort of a stealth startup company. Not many people knew about. And then in early 2020, reports began to surface about what they were doing. They're essentially a company that's doing Google for face images. So you can input a face image, and back to you comes all this information about the person you input. And they have good technology. They have done a very good job of matching faces and scraping the web all over the place with lots of data, and being able to come up with a large amount of data from a given query face. And there's a lot of concern about how that has been used, and especially how it might be used. There's also been stories about the misuse of their technology by their users, by their investors, by their friends. And for many people, thinking about this company, Clearview AI, and what it's doing in the face recognition space has been sort of an aha moment. That is, they look at this and they say, well, I don't know if it's legal or not, maybe it is, but it feels very creepy. It feels something that I don't want to be happening. And so it has raised a lot of concern and helped fuel, I think, some of the very significant outrage or protests or whatever against face recognition technologies. So back to things like the law enforcement use of face recognition technology. There is both push from various organizations throughout the world, and especially I know in the United States, in terms of border security, in terms of police, in terms of FBI and similar things, because many of these people see how these technologies can be effective and can help them catch thieves and terrorists and criminals and such. At the same time, there have been local and state level, and in some cases national level, bans for police and other organizations using these technologies. So it's sort of an interesting situation right now where these bans are being passed in various places at various levels, while at the same time the police in that same area might be saying, we need this, we want this in order to make you safe. And so there are lots of these ongoing discussions, and in some cases sort of heads butting from different organizations to figure out what's the right solution here. Do we stop it? Do we regulate it? Do we just let it go, period, or what? So I'll talk more about these conflicts in a bit. And then there's some interesting and concerning, at least, reports on China's growing surveillance state, for example, and also growing surveillance in Turkey fairly recently, and also growing surveillance in India. And these are just three examples. I'm not particularly intending to pick on or focus on, just these countries, but really to make the point that although crime is a significant issue and security and safety are important everywhere, there are also concerns in these countries and elsewhere about some of these efforts going forward. And so I think really, if nothing else, it's an important discussion for countries, for the world, for local areas to be thinking through, okay, what do we think about these technologies? How concerned should we be? How concerned are we? What are the possible ways going forward? So to kind of summarize to some degree these significant concerns, there's concerns about bias and treating different races differently. And different people of different ages differently, people of different genders differently, etc. There are issues of data privacy violations and consent. There are issues of lack of transparency and how these systems are deployed. There's lots of concerns about function creep, like they might be put in for a certain reason, but then individuals might choose to use them for different purposes without the knowledge, for example, of the citizenry or the government service that allowed them to put it in the first place. Concerns about the permanence of your face being, a permanent identifier for you, unlike a card or something like that could be changed. So really lots of concerns. And at the bottom there's still, for a lot of people, this sort of, it feels creepy to me. I'm not sure that I want this sort of thing. So if nothing else, these concerns are real, these concerns are significant, and they're growing all the time. And I want to summarize that. I just want to play this video, or at least part of this video, which is put together by an organization called Ban Facial Recognition. And it's really kind of put together to show what you might call an extreme, or at least, kind of far to one side view of the dangers and concerns and fears. So I think you should be able to hear my audio. Let me know if you can't, okay?
Facial recognition is sweeping across the country.
Okay.
Tech companies are building it, law enforcement agencies are using it, and our politicians are doing little to stop it. It's being used in deportations, where ICE has accessed DMV databases in different states to get driver's license data. People who legally signed up for driver's licenses had no idea that they would be used to deport them from the country. It's being used by police, where cops frequently misidentify people as criminals, putting women and people of color at higher risk. It's being used in our homes, where devices like Amazon's Ring feed our faces directly to the police. If you visit your friend's house, Amazon could send your photo to the cops without your consent. The police could keep your data forever, building a vast database of our movements throughout cities. Facial recognition is spreading fast, but momentum against it is growing. San Francisco and Somerville, Massachusetts just became the first two cities to ban facial recognition. Thousands of tech employees have called on their companies to stop working on facial recognition projects, warning of surveillance dangers. And politicians across the spectrum, from Alexandria Ocasio-Cortez to Jim Jordan, are warning of the technology's inherent dangers to civil liberties. We're calling for a federal ban on facial recognition. It's too dangerous to be deployed on our streets and in our homes. Facial recognition could drastically change our society, transforming it into a surveillance nightmare almost overnight. Like nuclear weapons, this tech is too dangerous to proliferate. It must be stopped. Join us in calling for a national ban on facial recognition.
Okay, I'll stop there. So this to me is sort of a good summary of that set of arguments. That basically we should throw this out. It's too dangerous to touch. It's like a new nuclear weapon that it would be better not to do. I'm not saying that I agree with this completely. I think it's an important perspective, though, to consider in this broad discussion about facial recognition technologies. Another thing that I think is really worth watching sometime, if you're interested in getting another perspective of this, there's a comedian. I don't know if you know the comedian John Oliver. He's a British comedian. He has a show in the US, a nightly show. Very funny guy, but also very insightful about politics and society and such. And he did a show on June 15th, 2020, so over about a year and a half ago, on facial recognition. And it's really worth watching. It's about 21 minutes long, I think. And it's both humorous and informative, and has a little bit different point of view of the one I just played, but is really worth watching, I believe, to get a sense of his perspective on these things. All right, so having said all of that, I want to look at a little different viewpoint now. So all of those concerns bring up the question, well, should we pass laws? What should we do if we are indeed concerned, either terribly concerned or at least a little bit concerned about the way things might be going? And of course, there are lots of possibilities from a legal point of view. There's regulation, there's bans, there's moratoria. And as I've sort of indicated, there are already laws around in various places in the world, but it's very kind of patchwork, covering different things, maybe covering just police or covering public areas or covering certain kinds of uses or covering the databases themselves. And they don't necessarily fit well. So it's really useful, I think, to think about these issues about who has authority to legislate in an area, in a topic like this. What can be legislated? Can it be addressed towards government or police or companies or individual use, or what? What are the appropriate tools? Regulation, banning, moratoria, penalties. Lots of interesting discussion in recent years about legal aspects of these things too. And so just as an example, in the US, there are all these different city bans now, and again, banning different things: police use, public use, things like that, and new ones coming up all the time. There's state legislation. I'm going to talk a little more about the particular Illinois state legislation, but others as well, and more coming all of the time. So the Illinois legislation, so I currently live in the state of Illinois. Chicago is in Illinois. And Illinois was the first state in the United States that 13 years ago passed this law called the Biometric Information Privacy Act, or BIPA. BIPA. BIPA is the oldest and strongest biometric privacy law in the United States, and it covers retina, iris, fingerprint, voice, hand, and face biometrics to some degree. And it basically requires companies doing business in Illinois to comply with certain requirements. And as it turns out, it's a little problematic from my perspective and from many of the companies' perspective, because I think it's not written entirely clearly, especially for face recognition. It uses these terms like biometric information, a biometric identifier, scan of face geometry, some of which are not really clearly defined or obvious from a technical perspective of what that means. And particularly, it defines biometric identifier as a retina or iris scan, fingerprint, voice print, or scan of hand or face geometry. So in the case of face recognition, this scan of face geometry is the phrase that actually matters here. Well, does a certain face recognition product do a scan of face geometry? Sometimes that's not so easy to answer. And I kind of suspect they didn't have really qualified technical people at the table, at the discussion, when they sort of came up with the specific wording of this legislation. So this has turned into many different lawsuits, and by far the most well-known one is a lawsuit against Facebook that happened over several years, and it was finally settled over the past year. Facebook has to pay is in the process of paying $650 million to various people because of this. And it turns out I was actually involved in this lawsuit in terms of technical expertise and making opinions on various things. So I got to talk to various lawyers and others about how face recognition works, what a neural network is, what deep learning is, what image alignment is for faces. Do these systems do a scan of face geometry? What's the difference between a holistic-based feature or a holistic-based approach or a feature-based approach? All these kinds of interesting technical issues, but they can be pretty complicated when you're talking to lawyers and trying to look at real legislation about. So I actually found it quite interesting. And so again, there's legislation coming up all the time in the United States, and including federal legislation. So in the US Senate and the US House of Representatives, nothing has been passed yet at the federal level, but there are a number of things in the works. You may have heard this year about the Artificial Intelligence Act in the European Union, and that's sort of a broad approach to AI, to approaching AI issues and concerns about safety and all with AI issues. And they've taken an approach of sort of this triangle here on the right, where there are lots of things that aren't too risky, a smaller number of things with limited risk, fewer things with high risk, and then presumably a fairly small number of things that are just unacceptable risk, and saying we just will not allow these things in the highest group there. The high risk group are the group of things that need to be regulated or watched over very carefully. As it turns out, face recognition technologies are in that category for the EU's Artificial Intelligence Act. So I'm very interested to see how this is going to play out over time with this fairly new act that by itself is not legislation in any given country. It's sort of guidance at this point. It's non-binding, but I suspect that this will become legislation in various formats in some European countries. So really everything I've said so far is really just kind of to make the point of this slide here, that all of these perspectives on face recognition technologies, technical issues, legal issues, ethical considerations, policy matters, they're all a balance. And they all balance on top of various cultural and society norms and expectations, which I believe do change quite a bit from area of the world to another area of the world, from country to country, from in the US state to state, or from city to city, or whatever. And so I think it's a good reason why there need to be not just technologists or not just legal people or policy people, but also ethical people, humanities people, history people at the table when these kinds of discussions are going on, and when societies and groups are deciding on legislation for these important things. So there are groups, of course, that influence those sorts of legislation or influence the lawmakers or try to. There are various professional groups, including, for example, in the ACM for computing. There are various industry groups. For example, there's a group called the Partnership on AI, which includes a lot of companies you would know quite well. There are companies themselves, companies like Microsoft, who I actually think has done a pretty good job in putting forward principles for face recognition and for artificial intelligence ethics that I think are pretty well done. There are various civil liberties groups, especially in the US, the ACLU, the Electronic Frontier Foundation, and others. And then other lobbying groups like this one I mentioned earlier, the banfacialrecognition.com, but others. And all of these sorts of groups come from different perspectives, but I think they're all, again, important to be in the conversation so that the society is really kind of appropriately represented in these important discussions. So again, I mentioned this one earlier, just wanted to put the website up there if you want to go check out, what they're saying. But, they're really kind of treating face recognition technology like a new nuclear or biological weapon, and treating it very seriously in terms of the reaction. And they're obviously very much in favor of banning face recognition technologies. Is that the only solution? I don't think so. But again, I think their perspective is important and should be included in this discussion. So we have this AI technology that's good, getting better all the time, but there are lots and lots of concerns about what it can be or is bringing about. It's a important question. Is it ushering in a dystopian Orwellian mass surveillance state in society? Or is it doing good things, or in some sense both? And if so, how can we balance those kinds of things? And if I just feel creepy about it, well, is that enough to ban it or something like that? Or should I really think through why I might feel creepy and maybe do a more systematic, analytic way of balancing, pros and cons and benefits and dangers and such? And, an important question is, when might it be too late to make certain decisions, letting the cat out of the bag, for example? And also, who actually is deciding this? Is it the people who scream the loudest, or is it the people who sit down and thoughtfully think through these issues and have the right people around them, inform them properly, and weigh the pros and cons of various solutions carefully? Should we all burn it all down, which is a phrase that John Oliver uses quite often in his video that I mentioned before, or should we think it through in other ways? And here again is just a push for the John Oliver segment, which I think is really, again, interesting to watch in this context. So all of this is getting for me to a technical question, which, okay, given all of that, still, what can technologists do? What, for example, can a PhD student do who's really interested in these areas and looking for a dissertation topic that might have some impact both in the societal issues as well as the technical interest that person has? And something that I think is really important here is that the old maxim that the weakest point of a chain is its weakest link. And I think face recognition technology is always in the context of a system. One of the key questions is, where are the weak points of that system? Are humans involved in that system? Are they involved enough in that system? Is a system making fully autonomous decisions that can have terrible consequence? Or are humans involved in appropriate ways when there's a significant consequence that might happen? And these are kinds of things that I don't think have been thoroughly enough considered. And in fact, there are a lot of directions of research that do think about systems engineering issues, that think about the data privacy issues involved in this, that think about the bias of particular data and particular algorithms, that how humans and AI systems can work best together and how they tend to influence one another. There are really lots of questions that have significant technical elements, but also can inform the broader discussion, or at least help in the broader discussion. And so I really am trying to push to some degree the kind of systems engineering approach to face recognition technologies, where we're really thinking about the full system, not only the specific technical piece, the algorithm, the data, whatever, but how it is actually used in real systems. And so, yeah, that includes a lot of things. Really, the bottom line of a slide like this is that there are all kinds of PhD dissertations, research topics, funding projects that are still possible. And there are conferences that have been popping up in recent years about fairness in AI, fairness in face recognition, and things like that. So it's really a fruitful area, I believe, for technical researchers, but then also for their colleagues in social science, in policy, in psychology, and other areas to think through a lot of these issues. Since I tend to be a interdisciplinary person, this kind of excites me, that there are all these areas that are important to society now, and I think are important for interdisciplinary work to be pushing forward. So it's also, of course, important to engage the policymakers, the practical people, the governments people, the company people who do things. But again, going back to the researchers, I think it's really good for us to be thinking always, what are the social consequences of my work? Are there potential costs to the things that I'm doing? How can I engage in a broader conversation about these sorts of things? So what can face recognition and more broadly AI researchers do? Lots of things. Just to mention one, for example, the NeurIPS conference in 2020 last year, and this is the biggest conference in machine learning. For the first time, they required that people who submit papers to their conference address ethical concerns and potential negative outcomes of their work when they submit the paper. This may not be the exact right solution or something that every conference has to copy exactly, but this sort of thing, I think, is a really positive step forward. And we'll figure, what the best thing is. We'll figure that out over time after some trial and error. But it's really encouraging to me that not only this, but other conferences are starting to look at really more deeply integrating these thoughts and questions about ethical concerns and possible consequences in the research for the researchers doing this kind of work. And I think there are other ideas like this that we can be thinking of and implement over time. Bottom line, in my view, researchers should be introspective to some degree and ask questions to themselves, again, about their work, their position about this. Are there opportunities for them to connect with other disciplines, other people? Are they thinking through the responsibilities of themselves, their group, their profession, their research community, the community and society as a whole? And just as a pragmatic matter, there, I think, is increasing amounts of funding for people doing interdisciplinary projects in things like this. So I think there's kind of a practical motivation as well as the kind of, ethical and human motivations for this kind of thing. So really just taking you through these various thoughts of these technologies, over the last 40 minutes. I just want to end with almost end on this slide, which is a quote from Rod Brooks. I don't know if you know who Rod Brooks is. He's a very famous former MIT professor who worked in robotics for many years at MIT. He started many successful robotics companies, and he published this quote earlier this year that said, just about every successful deployment of AI has either one of two expedients. It has a person somewhere in the loop, or the cost of failure should the system blunder is very low. So in other words, he's saying, if the cost of failure of a system is high, if there are potentially, very negative consequences of failure, humans need to be in the loop. I think the only question with these technologies, including facial recognition technologies, is where and how humans are in the loop. It doesn't necessarily mean that every face recognition decision has to have a human approving it or something like that, but the role of humans needs to be in the system, needs to be considered from the very beginning, I think, not just an afterthought. And the cost of failure in many of these applications can be very high. And so I think it's incumbent upon researchers, engineers, developers, and everybody really in the loop to be thinking about these questions. So in summary, I think facial recognition still has a lot of promise. I think there are a lot of important positive applications, really good things that face recognition can do and has done for society. But I believe the fears raised, the concerns that some of these groups like Ban Facial Recognition raises, they are significant and they're not to be ignored. And I do not think, at least for me personally, it's okay to say, well, I just do research. That's not my consideration. I think it is my consideration as being a human, basically. So there are various levels of responsibility for researchers, for developers, for deployers, personal, corporate, community, global responsibilities. And I think in terms of academia and actual, coursework for students and all, just adding a course in ethics might be a very good thing to do, but it doesn't really address deeply the issues here. I think we need to go beyond that in our academic programs. I don't think personally that either extreme, face recognition is just terrible, burn it all down, disallow it, period. I don't think that extreme is good. I also don't think the extreme that, oh, don't worry, these things aren't so bad. I don't think that extreme is good. I think, we really need to take those seriously and think through these things deeply. So a thoughtful, well-informed combination of technical, policy, regulatory approaches, ethical considerations, societal concerns can make a huge difference. There's plenty of common ground, and again, plenty of opportunity for people to work together in interdisciplinary endeavors. So that's really what I wanted to say. I wanted just to kind of guide you through that wide range of thoughts and opinions and situations. So thank you for your attention. And if we have time for questions, I'll be happy to take some.
Oh, thank you, Matthew, for wonderful presentation and lots of insight indeed. I hope that it will help all of us to move further and think differently on some topics as well. Now we have Dr. Anirban Bandyopadhyay from NIMS, Japan. So he is one of the session chairs. So he will handle that QA session. So Anirban, please.
Yeah. So thank you.
We have time, so enjoy.
Yeah. So thank you, Matthew, for the wonderful talk, and then it was really interesting. So before we take the questions, there must be definitely lots of questions. Atikur, could you please select a few questions?
People can write on the chat box. Otherwise, raise hand so that we can allow them to ask questions. But I have many questions, so if no questions, so I'm willing to start. Yeah, I start with the first one. So the point is that regarding the bias and racist issue, I thought about it before as well, that the number one reason we understand that the data set is biased towards one race or one kind of things. So that is one of the reasons. But any other reasons that, fails the technological part, like, one race is difficult to recognize, even though the data set is larger, something like that. So is there anything technical, because we know that in China they have huge data sets and they are much more successful. And in terms of, face recognition based policing or whatever you mentioned, China has the highest amount of surveillance cameras in the world, and they track and everything they do. And as it's a one nation, so it's very easy to track, because the data set is not diverse, mostly
Mhm.
one dimension. So in that regard, just can you give some insight whether there are technical issues or how to move forward to avoid the biasness, or especially on a specific race, which we found, recently, rigorously. Yes, thank you.
Yeah, so it's a good set of questions, and I think it's complicated actually, and I think it's more complicated than many than is often described, sort of like in the public press and such. I think that biased data sets are kind of obvious, right? That's a clear thing that in some cases has been extremely imbalanced, because the people making them, especially in the early days of facial recognition, didn't really think about that issue. They're just trying to see if it could work, and come up with ideas for algorithms and stuff. They weren't really thinking about practical deployment and such issues. But unfortunately, people kept not thinking about those questions, for a very, very long time. And so these data sets, not just in face recognition, but in all kinds of applications of AI, are quite often biased. But it then begs the question, what does the right data set look like? In fact, there's not a very clear answer to that question. It's still sort of a complicated set. For example, when the actual population is not evenly distributed among various demographics, whether you think sex, race, age, all kinds of ways in which we vary. What's the ideal data set for a situation like that in training? That's not even clear necessarily. And in fact, if the demographics, shows a certain distribution, is the right thing to have a data set that mirrors that distribution, or is the right thing to have a data set that makes them all equal? If it's the latter, then maybe your training is better, but there might actually be unintended consequences of trying to get more data from smaller populations than, relatively speaking, than the amount you get of the larger populations. And in some cases, it could mean, especially going to sensitive groups to ask for their data, which causes other kinds of, concerns and issues. So it's a complicated situation, I think. There's also sort of what I think you were alluding to, I think more fundamental algorithmic or maybe even in some case physics-based, or at least the combination of sensing and physics-based issues. Cameras are sort of well known to have been developed primarily for a certain range of skin tones, and they're kind of fine-tuned in terms of their electronics, especially sort of consumer level cameras and professional cameras, and those are better for some skin tones than other skin tones, and so they produce fundamentally images that have less dynamic range for certain kinds of faces than for other kinds of faces. So there are technical solutions to that, I believe, but not all obvious technical solutions of how you do that well. And it may just be the case that certain kinds of information are sort of have a lower dynamic range and when they're represented, in certain ways digitally, and so are going to lead to lower recognition rates for some kinds of faces, or in other AI applications, some kinds of groups of people or groups of data or whatever. So anyway, this is all sort of long-winded to say it's a complicated project, question, a set of questions, and I think there's definitely good prospects of moving forward and improving things, but I think it's actually a long endeavor, a long project to sort of incrementally push forward, make the data better, make the algorithms better, come up with better, generative algorithms to produce good synthetic faces for training and various kinds of things, understand the physics better than we do, and maybe, new ideas that none of us have thought of yet. I think there's still a lot of work to be done to get to this sort of ideal that we'd like to have of eliminating, those kinds of biases and inequities.
Thank you, Matthew. Thank you. Anibal.
Yeah, so we have a question from the audience. Actually, two questions, but Matthew, your comment have already included one question where one person suggested about light and then the camera, role of camera. You have nicely addressed that, so I'm not getting into that question. So another question is from Muhammad Asaduzzaman. Liberty and security are always conflicting issues and need to be reconciled by adopting appropriate regulations for a better society. Since FRT is not error-free, we can take FR as a prima facie evidence subject to corroborative evidence. So they want he wants a comment. I repeat the question. Since FRT is not error-free, can we take FR as a prima facie evidence subject to corroborative evidence? So this is the question. If I've got it, or I need to repeat.
Yes, I've got it.
Yeah,
and I think it's an important question that is sort of at the core of a lot of the things I was commenting on, and really kind of in a way, that question is what leads me to have the opinion I have that humans need to be in the loop more and more as the possible consequences of a decision get larger. And so, yes, face recognition is not error-free, except in the most trivial situations. And so, if a decision by a face recognition system is going to be linked to some action, if that action is, just how your game plays with you, then maybe that's not such a big deal. Fine to be, completely no humans in that loop. Okay. But if that decision is possibly going to lead to someone to be arrested, or for a system to call a black man a gorilla, or something very significant like that, then there needs to be humans built in, human interaction in some sense. How that works specifically, I think, again, depends on the severity of the potential negatives, and depends on the system itself and other issues like, is it a real-time system or not? For example, in policing, there tends to be a lot of opportunities for non-real-time human reviewing of things. In other scenarios that might have to be done in real time or close to real time, it might require other solutions, for example, just, if nothing else, a much higher threshold in order to determine, confidence that it's a face recognition match, but more complicated things as well. So anyway, in terms of this question, I completely agree with the framing of the question. And I think the real challenge here is, how do we then combine these things, take the evidence of the face recognition system, which, if it's built well, can provide good and useful evidence, just like a person can provide possibly error-prone, but still good subjective opinions about things. How do we best merge these various sources of information to come to a confident decision that we then can go act on, depending on how seriously that action is? So hopefully that addresses the question to at least some degree.
Okay, so Atiku, would you like to ask?
Okay. So as there is no other question, so I have another one. So this is a bit more technical again. Like, we know that deep learning is flourishing extremely high, especially face recognition. But if the data set is smaller, say we are working on autism and autistic children and their face study and so on. On that case, don't you think that the handcrafted features, classical features, still have some life or totally dead? What do you think about that? Or for example, the
yeah.
skeleton based, like, I mean, some of my works are related to skeleton based human activity recognition, where the data is smaller, healthcare applications. So I find that deep learning is not that much suitable. Rather,
Hmm.
I mean, handcrafted features can be, or classical features can be more suitable. So just some point from you. Thank you.
Yeah, good question. And to some degree, it depends on what the application or use of it is going to be, right? But one alternative. So let's start with this. I think what you pointed out is true. That in some domains, there's just not adequate data to train large, and the deep networks are getting deeper and larger all the time, right? And requiring more and more data, and they're getting trained better and better because of this. But yeah, some domains just don't provide that amount of data. So it might be that in those cases, kind of alternative approaches, like you mentioned, might be more effective. Again, kind of depending on the application. But another approach is using things like generative adversarial networks, or maybe some other technologies that can help create synthetic training sets. And it's possible, I think, even for a population like you mentioned, to learn enough about that population to be able to create pretty good and useful synthetic data sets that could then populate a large, neural network trained to do the kind of task you want to do, as opposed to, doing another method. And my guess, at least at this point, is that in the long run, that will be a more profitable direction, because these tools are just so powerful compared to, the way we used to do things 10, 20 years ago. But in certain applications, it may actually be that the more, handcrafted computer vision approaches, prior to the deep learning approaches, might work and might work quite well. But my suspicion is that's still kind of limited compared to what might be possible with synthetic data.
Thank you.
Yeah, just one comment I wanted to know about the future. So how do we solve this problem? I was just thinking that, of course, those people who have brown skin or black skin, they would never believe the argument that it is a technical fault, because they would say that why always the black people or the brown people or the dark colored people will be affected. So it may be intentional. So I was thinking how to find a solution. So could it be, the solution could be that instead of one camera directed from one direction, if I have 3 cameras, and then my AI algorithms are creating a 3D structure, and then if we build a database of from 3 different direction or multi-directional cameras are building, then the argument will not be there that it's a dark tone, that's why contouring, or I convert into grayscale, and then when I go for contouring, then for black face I have very little information, for white space I have a lot of high information. That kind of argument won't be, won't stand, because I will have 3 cameras and I can create a 3D. So since you are very expert, and then you have a global authority on particular this, is it possible to go for this kind of technology where we can permanently resolve this issue?
Yeah, there are still issues though. So as you may know, there has been a good bit of work in 3D based recognition in general in computer vision, but then also in computer face recognition as well. Not nearly as much work, as other approaches. But the limiting, or at least one of the limiting factors here, is that the canonical face recognition problem is you go to a certain location, you get your picture taken there, and you're recognized, like in a border security kind of scenario. But of course, that's not the only scenario in which face recognition is being used, or, people need to use it. People are using in existing videos, for example, in situations where the people being watched are very far away. So too far for any, at least current, 3D systems to create good 3D structures from the faces that are so far away, and maybe some, other scenarios. So in some kind of standard face recognition scenarios, what you said, I think, is completely good and would be quite helpful. Not that there still might be some issues about getting good 3D information, from darker skin because of the way cameras are currently constructed, but technically, that can be improved. But still, there are situations in which it's at least for the time being not easy to do the 3D part first. But there might be other methods as well. So that's actually good for people to be thinking about. Okay, that's one direction that you've brought up. Maybe there are other directions.
Yes.
And for example, things like your facial movement, and other things about you. But that's still kind of limiting. But there might be other things that we're not really thinking about at the moment, or that could be quite useful.
Spatiotemporal dynamics is definitely very, very helpful, because here in our lab, or here we work on spatiotemporal dynamics based recognition, not the static. Static is always problematic.
And of course, there's also non-visible light sensing and other potential approaches as well that can get around some of these questions.
Infrared and superposition of multiple sensory system, multi-directional system, and then multiple system has to be merged to bypass. It's very
multimodal, multi-camera, lots of things.
I think. Yeah.
But again, that presumes that you have control over the sensing, right? And in lots of situations, you don't. At least currently,
we don't have. We don't have.
Especially in the surveillance cameras, situations, it's very difficult to get this kind of. When we have constrained settings indoor, it's easier. But when we have, massive outdoor scenarios, it's very difficult. But still,
difficult.
These are. Possible. I have one last question, because nobody is asking, so I would like to take this opportunity that we are using masks nowadays massively all over the world, and it will continue. So give us some suggestions for the young researchers that how can we proceed on when half of the faces are, not visible, and sometimes you have mask and then sunglasses and hoodies, then you don't see anything. So these kind of things, so give some research directions or ideas, or points, so that, we can move on. Thank you so much.
Yeah, I'm not sure that I have any specific insight there, except just knowing that a lot of people have been doing this over the past year and a half or so, trying to do face recognition when wearing masks for obvious reasons. They want to be able to recognize people in public spaces and all wearing these. And there's actually been some very good successes. I believe NEC, which I listed earlier, is one of the companies, I think really one of the top companies providing deployed face recognition systems in lots of different places like airports and whatever spaces. I think they've gotten some very good results in face recognition under mask wearing situations. I've had some researchers here and there. I really haven't actually been following sort of, what's the special approaches that these folks have been using to get really good results with the masks. But kind of going back to your earlier question, I think certainly one component of it is building deeper and more parameterized networks, that are trained on masked images or images, just of certain portions of the face. And they seem to be getting quite good results. But it's not that it's a solved problem. And I think there are a lot of different ways of masking information, some occlusions that are on purpose, like wearing a mask of a certain kind. There are also the occlusions that are accidental or not on purpose. Probably during this talk, you've seen the sun or the light from the monitor reflecting off my glasses, for example, various things like that. So these are still issues, not only having to do with, COVID related masking, but issues that come up in lots of practical face recognition systems that they're partly solved, but they're certainly not fully solved. People can do better than they could do some years ago, but but still not great. And then sort of going back to the earlier conversation about multimodal and all that, there is the possibility of bringing together ear-based recognition, iris recognition, other sorts of things that could be helpful in more limited viewing situations as well. But again, I don't know that I have any great insight in specifically that question of where to go at the moment. I would look at some of the current successes and see what still is lacking and start there and brainstorm about where could we go from here.
Thank you very much, Aniba.
On behalf of the organizers, I would like to thank Matthew for your wonderful presentation and very energetic and enthusiastic presentation, and have your patience to reply to all the queries and concerns that we had. So we are really grateful to you to take out your precious time and coming here and then give us this presentation. As you know that we are celebrating the 50 years of independence of Bangladesh, and then your contribution to this will be remembered by the nation as a whole. So thank you very much on behalf of the organizers and on behalf of the nation Bangladesh to be a part of this celebration. Thank you so much.
Thank you for inviting me. I really appreciate it. And congratulations on the celebration. It's really important.
Yeah, so thank you, Matthew. I mean, by the way, Oniban is not a Bangladeshi.
Yeah.
Okay.
He's an Indian.
Okay.
At least the Bangla is speaking Indian. So
yes.
Gotcha.
Anyway, from my side, I definitely thank my great friend Matthew Turk, and many of us know him that he's the founder, chair of International Conference on Informatics, Electronics and Vision, which is ICIEV, for the last 10 years, and he's a world famous, highly contributing academic leader, and currently the president of Toyota Technological Institute at Chicago. If we praise him more, hopefully he can give us some Toyota Prius free of cost in the future. So that's the thing, and I'd like to invite you all to submit high quality chapters on a book which we are going to work together, Matthew and myself, and Richard Hartley and Upal. It's on computer vision and applications, trends and challenges. So if you have anything great, so please contact with us, or at least me. And finally, I'd like to invite you to stay tuned. Just after 10 minutes, we have two more presentations from two legendary persons. One is Stuart Russell. If you studied AI, his book is the book you studied. So Stuart Russell from UC Berkeley, and another one is our legendary person on robotics and great friend of mine, Professor Toshio Fukuda from the Meiji University and Nagano University, and we all know we voted for him last year. I mean 2 years before. He was the president of IEEE, first time from region 10 like Asia Pacific in the history of IEEE. So Toshio Fukuda is a great friend of Bangladesh as well. He visited Bangladesh several times and attended ICIV and IVPR conference. He's one of the general chairs of IVPR as well. So we hope to enjoy their talk. So stay tuned. Just take some coffee or something else. Within 10 minutes, we'll stay and join. Thank you so much. Thank you, Matthew and Oniban. Thank you. Shamim.
Professor Kaisar ki achen? Hello.
Professor Hafiz, assalamu alaikum.
Walaikum salam, Dr.
Walaikum salam.
Walaikum salam. আপনি ভালো আছেন, প্রফেসর কায়সার? হ্যাঁ, আপনাকে জি একটু জানতে চাই, আমাদের সেশনে তো দুইজন চেয়ার, কে কিভাবে মানে
স্যার প্রথম স্টুয়ার্ট রাসেলকে আপনি ইন্ট্রোডিউস করাবেন, আপনি কোয়েশ্চেন আনসারের হেল্প করবেন, আর ইঞ্জিনিয়ার আবু বকর হানিফ, ওই চ্যান্সেলর আই গ্লোবাল ইউনিভার্সিটি ইউএসএ, উনি সেকেন্ড স্পিকারকে হ্যান্ডেল করবেন, এবং আপনারা দুইজনই সাপ্লিমেন্টারি কোয়েশ্চেন একজনকে করবেন, সেটা হলে ভালো হয় আর কি স্যার। সো পুরো সেশনটা আপনারা দুইজনই একসাথে ম্যানেজ করুন, বাট
আচ্ছা
ফার্স্ট জনকে আপনি করলেন, সেকেন্ড জনকে হচ্ছে গিয়ে আবু বকর হানিফ স্যার করলেন। তাহলে
আবু বকর হানিফ কি মিস্টার আবু বকর হানিফ, আর ইউ হিয়ার? হ্যাভ ইউ বিন জয়েন?
আমি তো দেখতে পাচ্ছি স্যারকে।
আচ্ছা, উনি তো, আমি অবশ্য মিস্টার হানিফ,
স্যার কোনো কারণে যদি উনি ডিসকানেক্ট হয়ে যায় তাহলে স্যার
আমি তাহলে আমি টেক ওভার করবো, ঠিক আছে?
রাইট স্যার, রাইট স্যার।
জি জি, থ্যাংক ইউ, অসুবিধা নেই। তাহলে আমরা ওয়েট করি, আমাদের স্পিকারদের জন্য ওয়েট করি, দেখি ওনারা জয়েন করলে
হাফিজ ভাই তো ফ্যান যেহেতু ঘুরতেছে, আপনি বাংলাদেশি আছেন, রাইট?
আমি বাংলাদেশে আছি।
মানে
ফ্যানটা কি
অনেক
অড লুকিং মনে হচ্ছে? অফ করে দিব?
না, ফ্যান অনেকদিন মিস করি।
না, যদি সেটা তোমার
না,
মানে
পারফেক্ট। ডাইভার্সিটি মেক্স আস হ্যাপি। আপনার পিছনে ফ্যান না দেখলে আমি হয়তো আনন্দটা পেতাম না।
না, আমি
another
অফ করে দিয়ে
না,
দিতে পারি,
প্লিজ
ফ্যান অফ করে।
না,
কোট করে ঘরের ভিতরে কোট করে গরম লাগে এটা।
ওকে। না, এটা বললাম এই জন্য যে ওই যে আবু বকর হানিফ উনি তো ইউএসএ থেকে করবেন, কোনো কারণে যদি টাইমিং এর প্রবলেম
হ্যাঁ,
আপনি ধরেন যে এটা হ্যান্ডেল করবেন নাকি?
আমি
ওকে, থ্যাংক ইউ।
বাইরে করতে তো 5 নম্বর বলতে বাসতে তো
আমি কি জিজ্ঞেস করব, প্রফেসর স্টুয়ার্ট রাসেল and প্রফেসর তোশিও ফুকুদা, are you in the Zoom meeting by now? No, nobody is responding yet. Okay, let us wait. আতিক, তুমি মানে বাংলাই বলি, আমাদের তো স্পিকার আসেন নাই, বাকিরা আমাদের মনে হয়, I think most of we are from Bangladesh anyway. I think it is in international conference we should talk in English. So yeah, you may help in the question answer session. May raise some interesting questions which actually stimulate the discussion.
I'll try. But basically,
okay,
I mean, if it is related to my area, and if I
I
understand,
think
don't understand
we
something,
are,
so I ask.
yes, no problem. AI is
Okay.
new. I mean, not within my area, but I'll try to ask some question myself.
Yeah, no problem. Actually, Professor Fukuda is a very good friend of mine. We've had
Okay, glad to know.
interactions
that
many
is very,
times.
very
We visited each other many times and lunch or dinner together great number of times. So and his research area is definitely, colliding with me. Stuart Russell, his topic is very challenging, but I think that as we discussed with him earlier, through email, that it's on AI, a bit lightweight AI stuff, so that people can understand, less technical. So
yeah, I think his topic is more public oriented. These today's topic, the provable beneficial artificial intelligence. So I think it will be very interesting for us.
we have a good audience on site and online, but I don't think that whether we can get the questions. I request, the organizers, that if you can just copy any questions from the Facebook Live or YouTube Live to this Zoom chat box, then session chair can share. That would be one option. Otherwise, we can't see the questions from them. Definitely, they have questions. Please. Oh, thank you. I'm tired of having online conferences. I love to travel and enjoy and meet people. By people, I mean the researchers globally, and that's a good enjoyment. Yeah. So there is a raise hand from CH. Okay, no, that's a mistake. Shamim Kaiser, are you around?
Yeah, he was here within the at audiences. Our first speaker, Stuart Russell. Professor Russell? No, he's not here still. Okay, so we are very close to the starting time of our program. Professor Shamim Kaiser, are you here?
Sir, I'm here. I'm trying to contact with Stuart Russell.
Okay, thank you.
Professor Shahzad actually emailed him, and he replied he will join in time.
Okay, okay.
So I'm
Maybe.
trying to contact him, yeah.
Okay, thank you.
Yeah, I also emailed him and he's
Okay.
probably.
Sometime, I mean, it may happen that there is like on United States,
The
it is
previous,
10.
like, I mean, 2 months before you make a plan, and
Yeah,
just now
yeah.
the daylight saving things. So,
Yeah, that's true. That's true.
yeah.
Time has shifted.
And another thing is that some people think that India, Bangladesh, Pakistan, this region, we have the same time zone.
Yeah.
So this
Yeah,
morning
actually,
happened.
it is 10th in the United States, and when we are 11th December, that is also, I mean, day shift. So that could make someone confused sometimes.
Atik bhai.
Yeah.
Professor Fukuda, he will give recorded lecture, right?
This is, he said, but I mean, then I told him whatever he prefers.
Okay.
So the last, yeah, so last email, I mean, he will join. I mean, this is the plan. Yeah.
Okay, okay,
because
got
he
it.
did not send us the record lecture. He will fly. So better I just email him again
Yes,
with the
please.
time. Yeah, so that I mean he can join. আমি দুইজনকে মেইল করেছি, লেটস সি। তো হওয়ার কথা না, বাট
আতিক ভাই, স্টুয়ার্ট রাসেলকে যে টাইম পাঠানো হয়েছে ঠিক আছে তো না? দেখলাম ঠিক আছে মনে হচ্ছে।
হ্যাঁ, ভুল থাকার তো কথা না। মানে আমি তো আর টাইম পাঠাই নাই, বাট তোমরা যে পাঠিয়েছো সেখানে ভুল ছিল না বলেই আমি জানি। But meanwhile, I mean, the audience participants, we can interact each other, discuss, I mean, about the conference or any topic. I mean, that's also,
and that could be done.
yeah. I mean, they have some networking. I mean,
Yes.
those who are on site, they are not only having networking, they are enjoying food as well. Some sort of.
আমাদের এখানে তো অনেকেই মনে হয় বিভিন্ন ইউনিভার্সিটি থেকে আছেন। Some of many of you are faculties or in industry. By this time, since our speakers, both of the speakers and also the another chair of the session, all of them are not here. I think it is okay for everyone to turn on your microphone if you want to talk. We can actually have some interactive discussions regarding issues related to the fourth industrial revolution or AI, if you like to. That is okay from our part. Can anyone turn on microphone? Dr. Atik or Dr. Kaisar? Shamim Kaisar. তারা কি পারেন নিজেরা? I don't know.
Hello, sir. I am Dipto Bishesh from University of Borishal.
University of Borishal. Wow. Yeah, glad to know. Are you a faculty there?
No, sir. I am a student, and I'm a final year
okay.
graduate student, and I am very glad to have acceptance from this conference, such prestigious conference.
Yes.
And my presentation was in the last day, and this is my first achievement actually, and I'm working on natural language processing and machine learning. So this arrangement is such a great opportunity to us and to our student actually.
That's true. That's true. Yes, we every one of us we thank University Grants Commission for taking the initiative on this historic moment to have this conference. They deserve our praise.
Yes, sir. There are two professors who will take part, I think so. But I have a little question to them, and I have already sent to the IC4IR room 1.
Yes, I think then you wait. We are expecting that they will join soon. There may have some communication gap because they are in different time zone, and it is actually like start of the weekend for them, Friday night. So sometimes people tend to occupy with other things. So that
Yes, sir.
may make some misunderstanding for them.
Yes, sir. Though I am very little, but I have a general query that how can I prepare myself as an AI researcher?
I think if you want to be a researcher, you have to actually go for higher studies, master's, PhD, and without formal academic degrees, it is difficult to become a researcher in present world. With bachelor degree, you cannot do much quality research. So I think your focus should be now to do good in your coursework at your undergrad degree,
Yes,
and
sir.
try to improve your English and try to get admission to a good university in English speaking country, I would say, because there are also very good research in Japan and other places. I have full respect for that, but I think sometimes the language, English language helps because we studied that our all over our education in English. That
Yes,
would
sir.
be helpful. But if you like, there are like German universities, Japanese universities, they are equally good, but you may have to learn their languages. That is another requirement you have to think.
Thank you, sir.
Some aspect. We got some noise from someone's microphone. Is it okay? It's stop now. Okay, so I think our speaker, Professor Stuart Russell, joined. So I welcome you, Professor Russell. This is where we are really glad to see you among us. So I may formally start our session now. So all the audience, so our main speaker for our session, Professor Stuart Russell, is here. So let me formally start our session. So today we have two very distinguished professors, very distinguished researchers among us. Professor Stuart Russell, and the next to him will be Professor Toshio Fukuda. He's not here still. But first, we will have our presentation from Professor Stuart Russell. So his topic is provably beneficial artificial intelligence, which is very important topic in today's context, especially when we have some type of negative connotation within our mind about the AI, especially many of us have seen like movies like Stanley Kubrick's famous 2001 A Space Odyssey to the recent days, The Matrix or The Matrix Resurrection, which actually portrays AI as the against our human existence, something like that. I think we have one of the world's foremost authority in front of us who will try to address that fear or OD is unfounded, and we will start feeling comfortable with the evolution of AI. So let me introduce our speaker first. So Professor Stuart Russell received his BA with first class honors in physics from Oxford University in 1982, and his PhD in computer science from Stanford in 1986. He then joined the faculty of the University of California at Berkeley, where he is a professor and formerly chair of the Electrical Engineering and Computer Sciences and holders of the Smith-Jade Chair in Engineering. He is also an adjunct professor of neurological surgery at UC San Francisco and vice chair of the World Economic Forum's Council on AI and Robotics. Russell is a recipient of Presidential Young Investigator Award of the National Science Foundation, the IJCI Computers and Through Award, the World Technology Award, Policy category, the Michels Prize, and the American Statistical Association and the International Society of Bayesian Analysis. the ACM Carlstrom Outstanding Educator Award, and the AAAI Outstanding Educator Award. In 1998, he gave the first memorial lecture at Stanford University, and from 2012 to 14, he held the Carly Blaise Pascal in Paris. He is a fellow of the American Association for Artificial Intelligence, the Association for Computing Machinery, and the American Association for the Advancement of Science. His research covers a wide range of topics in artificial intelligence, including machine learning, probabilistic reasoning, knowledge presentation, planning, real-time decision-making, multi-target tracking, computer vision, computational physiology, global seismic monitoring, and philosophical foundation. His books include the use of knowledge in analogy and induction, do the right thing, studies in limited rationality, and the artificial intelligence, a modern approach. His current concerns include the threat of autonomous weapon and the long-term future of artificial intelligence and its relation to humanity. So I welcome you, Professor, to give your much awaited speech so that we can become enlightened and actually appreciate the role of AI in our life, because we foresee that AI will be one of the key elements for the coming days, the fourth industrial revolution, what we is termed by this time. So I welcome you to our conference, which is being organized by our country's epic body, University Grants Commission. I thank you for joining us. Please.
Thank you very much, Dr. Rahman, for your very kind introduction. And congratulations on both the 100th anniversary and the 50th anniversary that you're celebrating this year. So I don't think I'm going to just reassure you that everything is completely fine with artificial intelligence, because I don't think that's actually true. I think there is a way forward, but it might not be the one that we're currently following. So let me begin by getting agreement, shall we say, on what we mean by artificial intelligence. Of course, it means making intelligent machines. And what that means, or what it has meant since the beginning of the field, is a definition that in many ways was borrowed from economics and philosophy, developed in mainly in the first half of the 20th century, the definition of rationality or rational behavior. So in the standard model of AI, machines are intelligent to the extent that their actions can be expected to achieve their objectives. And within that standard model, there are many different types of artificial intelligence, depending on the characteristics of the decision-making problem that this intelligent system faces. So for example, the oldest fields within AI are problem solving, constraint satisfaction, and game playing, where we have a discrete decision environment, a well-defined objective in terms of a goal to achieve, or a definition for winning a game or satisfying constraints. And we've developed very, very successful algorithms for these domains. There's also the area of knowledge representation and reasoning, both logical and probabilistic, which has had many successes. And for example, Google's knowledge graph is a logical knowledge representation system that supports question answering and has about 500 billion facts and answers about 1/3 of all the search engine queries in the world. And that includes some ability for natural language processing on the query side, But of course, natural language processing has many, many other applications, as do speech, vision, robotics, and so on, leading up to things like self-driving cars. And underlying a lot of the progress in the last decade is machine learning. And nowadays we build many, but not all, of the high-performance AI systems using machine learning techniques. But the systems that we have built so far, the successes we've had, have mostly been fairly narrow. Systems for playing chess, systems for driving a car, systems for recognizing images, and so on. But the goal of AI is now, and always has been, general purpose AI. That's a system that is capable of quickly learning high quality behavior in any task environment where humans can function. And probably if they can do that, they'll be able to do well in many environments in which humans cannot function because of the massive advantages that machines have in terms of bandwidth, memory, and computational speed. So the question we need to ask, given that that's the goal we're all working towards, is what happens if we succeed? So if we are on a journey, what is the destination, and do we want to get there? So if we look at the positive aspects of success in AI, in creating general purpose AI, we could use general purpose AI as essentially an unlimited supplier of goods and services, because it can do anything that human beings can do, but doesn't need to be paid. That's a very simple way of putting it. We could use general purpose AI in the form of both cloud computation and the physical embodiments in terms of robots, vehicles, and so on, to lift the living standards of everyone on Earth to a level that we might call respectable, where the difficulties of daily life are largely eliminated. And this would represent approximately a 10-fold increase in the GDP of the world. So we're not actually proposing, at least with this ambition does not require us to do things we don't know how to do, right? We already know how to do this for hundreds of millions of people on Earth, but not for the entire population. So it's just scaling up and making much, much, much more efficient what we already know how to do. And the cash value of that, what the economists call the net present value, would be about $13.5 quadrillion. So that possibility itself, which I think is quite conservative, creates a huge amount of momentum and partially explains why major countries are making such huge investments in artificial intelligence. I think it also creates an unstoppable momentum for those investments. We could also do other things beyond that. We could have much better healthcare than even the most wealthy people enjoy. We could have education that caters to the individual potential of each child separately in the way that a very skilled human tutor could do, but this would be possible on an enormous scale. And I think we're already seeing that AI is contributing to the rate of scientific progress, and that could become much greater in future. So these are all extremely positive developments. And we could describe this really as a golden age for humanity. So Alan Turing, this is a picture of Alan Turing. He's the founder of computer science. And in a famous 1950 paper, Computing Machinery and Intelligence, he laid out a vision for AI, including many of its subfields, as well as machine learning. But in a 1951 lecture, he asked the question, what if we succeed? And his answer was as follows. It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control. So that's a much more pessimistic view of success in artificial intelligence. He offers no solution. Just in some sense, you get a sense of resignation from this description. And so now if we move forward in time, we have seen come to pass some of the dreams of AI researchers that at one time seemed out of reach, but now we have self-driving cars. We are able to beat human beings at more or less every well-defined game that we play, whether it's chess or Go or poker or bridge or modern video games. AI systems readily defeat almost all or sometimes all human beings. This is some results from my own work. This is the monitoring system for the Nuclear Test Ban Treaty. So we have a global system of seismic stations that collects seismic information and then uses that to pinpoint seismic events occurring anywhere on the Earth, and then hopefully detecting clandestine nuclear explosions. So this shows the detection of a nuclear explosion in North Korea. This is a satellite image of where the explosion took place, and the tunnel entrance is marked at the bottom, showing where the nuclear testing facility entrance is. And then the net visa location, this is our algorithm. And it's one of the largest probabilistic reasoning systems in existence, using millions of random variables and very sophisticated forms of probabilistic inference to process all of this data and identify these kinds of events. Now, of course, there are things happening with AI that we're not happy about. So we know that AI systems can, in some cases, produce decisions that are racially biased or biased by gender. We know that it's now possible to produce extremely realistic impersonations of human beings. Here are 4 people. It's very hard looking at these images to see which is the real person and which is a completely fictitious, non-existent person. And I'm glad to report that the European Union is, I think, about to make it illegal for machines to impersonate human beings. So every machine has to identify itself as such when it's interacting with a human being. We've also seen the use of AI to create and amplify disinformation, which is causing a lot of problems around the world. People worry about AI systems replacing human beings in many jobs. And I think ultimately that is going to happen in the sense that the jobs that are routine, that require human beings to engage in repetitive, tedious behavior that taps into only a tiny fraction of their human abilities, I think those jobs are going to be replaced by machines because in many ways we are using human beings as machines in that type of work. But of course that leads to the question of what human beings will be doing if machines are doing a lot of what we currently call work. And some visions of that future are less desirable because as we lose the incentive to gain an education in order to be economically viable, we actually become enfeebled and even infantilized, as shown in this film Wall-E, where the robots are running civilization for us, and then we sort of lose our own intellectual vigor as human beings. And of course, there are even worse uses of AI, such as creating machines that can decide to kill human beings. And people used to think of this as science fiction, the Terminator robots and so on, but of course this is real, this is happening, and the world appears unable to prevent the emergence of an entirely new class of weapons. Now, I don't want to say that general purpose AI or human level AI is imminent. I'm not one who believes that simply scaling up our machines, making them faster, making them bigger, collecting more data is going to lead to human levels of intelligence. There are some major gaps in our conceptual understanding. Here are just 4 of them. And I think possibly the most important one is the third, our ability for long-range thinking at multiple levels of abstraction. So if you think about what our brain does, our brain really controls the muscles of the body. And those muscles produce speech, they produce typing, they produce lots of other physical behaviors. But the time scale of speech and typing is a few milliseconds. That's the relevant time scale on which the brain controls those systems. But we make decisions at all levels, even up to multiple years. A student deciding to do a PhD is committing to 5 or 6 years where they're working towards a particular goal. And that's about 1 trillion motor control actions. And we are able to make plans seamlessly at every level from milliseconds up to years, and to do so fairly successfully. And this is something that we really have very little idea how to get machines to be so successful in the real world. So I would say it's very unpredictable when these breakthroughs will take place. And to illustrate how unpredictable they are, it's, I think, instructive to look back at history and say, when was the last time we invented a potentially civilization-ending technology? That was in the 1930s. And the physics world had known since 1905, since Einstein's special relativity work, that the atom contained a huge potential reservoir of energy. They could calculate exactly how much could be released by transforming one type of atom into another. But it was widely stated and believed that this was impossible. And Lord Rutherford, who was the leading nuclear physicist at that time, was asked at a meeting, do you think it's possible even in 25 or 30 years' time that we'll be able to release the energy of the atom? And he basically says, no, it's completely impossible. Moonshine is the word that he used. And Leo Szilard read about this in the newspaper the next morning and went for a walk and invented the neutron-induced nuclear chain reaction, which is basically the solution to the problem that Lord Rutherford said could not be solved. So we went from infinity to about 16 hours for creating atomic energy, which was, as Leo Szilard very well understood at the time, an extremely hazardous discovery for the human race. So I think we have to operate on the assumption that at some point, not in the infinite future, but in the possibility in our lives or the lives of our children, we will have AI systems that can make better decisions than humans in the real world. And that brings us back to Turing's point. That means we're creating entities that are more powerful than human beings. And the question is, how do we retain power over them forever? Turing obviously doesn't see a solution, but I think we have to try to find a solution to this problem if this is the destination towards which we are moving. So to understand where things go wrong, it helps to go back to the way we think about artificial intelligence. As I said at the beginning, machines whose actions can be expected to achieve their objectives. And this standard model is actually more widespread than just AI. Control theorists use this. They minimize a cost function. Statisticians minimize a loss function, and economists maximize a utility or a social welfare function. So this idea of creating machinery into which we plug objectives, and then the machine finds the optimal solution to the objective and then carries it out. This is a very powerful methodology, and it figured very heavily in the progress that occurred in the 20th century. But as we move into the real world, it becomes more and more difficult to specify these objectives completely and correctly. And what that means, in fact, is that this standard model, this methodology that's so universal, is actually very difficult to employ and really becomes infeasible. And we've known this for a long time, right? Here's, this is a picture of King Midas, who's an ancient Greek king who, legend has it, asked the gods to give him the power that everything he should touch would turn to gold. So that was the objective that he specified, and the gods figured out the solution to it and carried it out. And then, of course, his food and his drink and his family all turned to gold, and he dies in misery and starvation. This is Walt Disney's version of the Sorcerer's Apprentice, who asked the brooms to fetch the water because he's too lazy. He forgets to specify exactly how much water, so they keep bringing more and more water and flood the house. If the genie grants you 3 wishes, your 3rd wish is usually, please undo the first 2 wishes because I've ruined the world, right? And many, many cultures have the same basic legend dressed up in different words. And now we're seeing this legend come true in the present. Social media algorithms, the algorithms that are sometimes called recommender systems, that choose what news items people see in their social media news feeds, choose what video is presented next when they're interacting with video servers. These algorithms are designed to optimize an objective that's specified by the corporation. And typically, it's something like click-through, the probability that the user will click on the next presented item. It can also be engagement, the amount of time the user spends interacting with the system. And you might think, well, the best way to maximize click-through is to learn what people want and send it to them. But of course, we know that that's not what actually happens. One of the things the system learns to do is not what people want, but what they're actually willing to click on. And those are not the same thing. And we have something called clickbait, which are things that will cause people to click, even though they're not actually the things that are necessarily interesting or even true to read. But it's much worse than that. The optimal solution for maximizing click-through is not to send people things that they will click on. It's actually to change who they are so that in future, they will more reliably click on the things that you send them. And so this is actually the optimal solution for maximizing click-through. And this appears to be what the algorithms are doing. They have learned to send chains of content that over the course of weeks or months, through tens of thousands of individual interactions, gradually nudge people in various directions. The algorithm doesn't really care which direction it nudges you, as long as it's nudging you towards a more predictable version of yourself, which might be a more extreme version of yourself, someone who is more willing to consume extreme content and do so voraciously. So this is the solution that the algorithms find to this maximization problem. And of course, we know, at least it's widely believed, that this is contributing to extreme polarization in our societies. And these algorithms are very, very simple. They don't even know that human beings exist. They don't know that we have minds or knowledge or taste or preferences or anything. As far as the algorithm is concerned, you are nothing but a click history. If the algorithms were better, if they were more intelligent, if they knew more about human psychology and human society, they would be far more effective than they already are in manipulating human beings. And so the outcomes would be far worse. And so we have a methodology where, as we improve the capabilities of our AI systems, the consequences for human beings become worse and worse. And I put it to you that such a methodology is poorly designed. So instead, I think we need a different model for how we build AI systems. Right? This is the existing model, and I think it doesn't work. The changes we need are not that great. What we want are machines that are beneficial, meaning that their actions can be expected to achieve our objectives. Those are the objectives that are in us, not the ones that we write down or the ones that we put in the machine, but our true preferences about the future. And this is a more difficult problem because it's hard to achieve an objective that's in somebody else and that you may not even know about. But this is actually the definition of the problem that we should be solving. We don't really want general AI systems in the sense of AI systems that can achieve any objective, including the objectives of all the cockroaches in the world, right? Why are we building machines that the cockroaches could use to turn the world into a huge pile of cockroach food? That doesn't seem like a technology that we would ever want to employ. So let's make machines that are beneficial to human beings. So we can express this in three principles, right? The first principle is that the robot's only objective is to satisfy human preferences, meaning, and preferences here is a very general word, meaning which future we prefer. Right? Imagine taking all possible futures of the universe and then ranking them. That would be the preference of a particular person. And then, of course, everyone has their preferences. They can all be different, and that's fine. The key point is the second principle, that the robot is uncertain about what those preferences are. And this, I think, is inevitable, because if we can make mistakes in specifying our preferences, then the robot should know that whatever we say is not necessarily the true preference and should be uncertain about what the true preferences are. But there's a connection between preferences and human behavior, because our preferences is what drives our behavior. So they are expressed as behavior, and therefore by inverting that process, we can get evidence about what people's underlying preferences are. And so this, in a very general sense, it's possible for machines to learn more about human preferences from the evidence provided by human behavior, and not just our behavior, you know, the artifacts that we produce, every historical document, everything we say, all of this is evidence about how humans would like the world to be. Now you can take those principles and produce a mathematically well-defined decision problem called an assistance game. So it's a game in the sense of game theory and economics, because it's a two or more decision-making entities, at least one human and at least one machine. And it's assistance game because in this game, the payoff of the machine is the payoff of the human. Whatever it is that the human is trying to bring about, that's what the machine wants. But the machine doesn't know what that payoff actually is. So you can write down these games mathematically and you can solve them and you can look at the solutions. And indeed, the systems that solve these games, the machine half of this game, has very desirable properties. They will defer to human beings. They will ask permission before changing the world in a way that they're not sure that we prefer. And in the extreme case, they will allow themselves to be switched off. And I'll go through that argument in a little bit of detail in a minute. So it appears that this new model of AI with uncertainty about human preferences actually gives us control over AI systems in the way that Alan Turing did not believe was possible. And we can show that it's rational for us to build machines that solve these assistance games. And they have the characteristic that as you improve the AI part of this, as the AI system becomes better at solving the assistance game, the results are better for human beings rather than worse. So let me give you a simple real world example so you can imagine what it's like to be the machine in this game. Okay, so you are the robot. Your partner, husband, wife, friend, whatever it might be, is the human being. So there, as you know, your partner's preferences are the things that matter, right? And you have to buy a birthday present. And to factor out the issue of who's paying, we're going to have the money come from a joint account. And as you know, this is a very difficult problem. You're not always sure to get. Previous years, you've got it wrong. But the key point here is that your payoff, at least in this problem, is precisely how happy your partner is with the present. So your payoff is your partner's payoff. But of course, you don't know what that is. And so that's the same position that the machines are in. And so what do? Well, you might try to collect more information. You might leave pictures around the house of different kinds of possible presents and hope that they say, oh, that's a lovely looking briefcase, or, oh, I really like that car, or whatever it might be. You might ask their friends, you might ask them, but of course they may not want to tell you because they don't want to ask for something that's really expensive or self-indulgent. But this is an example that I hope will convey the idea of what position the machine finds itself in trying to solve this problem. Now, of course, as you know, this particular kind of problem is unsolvable, but all other instances of assistance games actually have solutions, and we can start to look at the properties of those solutions. So let me look at one of those problems, which is how do we get a machine to agree to be switched off? And just to make it very concrete, here's the robot from our lab, the PR2. It's about a 200 kilogram robot. So it can be a little bit dangerous, and it has a big off switch on the back. Now, if we program this robot in the standard model of AI, we give it a fixed objective, like fetching the coffee. As soon as we give it the objective of fetching the coffee, it now has an incentive to disable the off switch, because being switched off would result in failure to fetch the coffee. And so by giving it any fixed objective, it's going to do things like disable its own off switch, because obviously you can't fetch the coffee if you're dead. So we don't want robots that disable their off switch. We want to retain control. We want to be able to switch them off. But it seems like the standard model almost automatically loses control. But a robot that doesn't know the full extent of human preferences about the future won't behave this way. So let me illustrate that with a simple decision problem. And I apologize to those of you who don't like diagrams or mathematical symbols, but it's really not very complicated, right? So it's like a little game. The robot gets to go first. And initially, we're going to give the robot two choices. To the right, we have the choice to switch itself off, to commit suicide. And we'll say that from the point of view of the human, the value of that choice is fixed at 0. On the other hand, the robot could push this very attractive big red button, which perhaps starts a nuclear war, perhaps it sets off the sprinklers in the building, perhaps it makes a cup of coffee. So the robot is uncertain about how desirable this choice would be for the human. And I've illustrated that here with the probability distribution. So there's uncertainty about the value. The x-axis is the value, the y-axis is the probability. So we can see there's a lot of uncertainty. There's a potential downside in the negative quadrant, which is quite large. But on average, it's slightly positive. If you took the mean of this, it's slightly more than 0. So it's slightly better than committing suicide. And so if those were the two choices, the robot would push the big red button, incurring a significant risk for the human. But what we're going to do is we're going to allow, and I guess I would say pushing the big red button is like disabling your off switch. It's preventing the human from interfering in the decision. But we're going to also give the robot a choice. Maybe it should just wait and allow the human to intervene, right? So this is not disabling my off switch. And then the human has a choice to press the off switch, which again will have value 0, or the human can allow the robot to go ahead. So you might ask, well, why would the robot choose to let the human do what the robot can already do, which is to switch itself off or go ahead? And the answer is because the robot and the human are in different information states. The robot doesn't know the human payoff, whereas the human does know the human payoff, at least in this simple model. So if the human says go ahead, that's because the big red button is not dangerous. So the negative quadrant, where it's a nasty thing to do, disappears. And now we know, the robot knows that pushing the big red button is safe and can go ahead and do it. So this is a very simple argument here. But what it shows, in fact, is that the robot has a positive incentive to allow itself to be switched off as long as it is uncertain about the human preference for which choice to make. And as soon as that uncertainty disappears, the incentive to allow itself to be switched off also disappears. And secondly, we can show under slightly stronger assumptions that such a robot is provably beneficial to human beings. So there's lots more to be done. And I'm sure if you're listening at all, you're probably thinking of all kinds of complications, and you're right. This is much more complicated than I have explained. We have to deal with many humans, decisions that are made on behalf not of one person, but many people, which is something that moral philosophers and economists have studied for thousands of years. When we have many machines all trying to help human beings, we have to make sure that they don't interfere with each other. The connection between our preferences and our behavior is a very noisy one, and I'll talk a little bit about that. And then we actually have to rebuild artificial intelligence, because we have built artificial intelligence on the false assumption that the objective is always perfectly known. And so we can think of that as just a special case, a very small special case of the general case where the AI system will be uncertain about the true objective. So this means both rebuilding the theoretical foundations and then creating applications of the new theory and the new algorithms. So let me briefly mention questions having to do with real humans. And as I said, with real humans, the translation from human preferences into human actions or behavior is an imperfect one. Humans are computationally limited. We can't actually make the best choice in all cases. If we could, we would never lose a game of chess, even to the best computer in the world, because we'd always be making the right choice. But of course, we can't do that. We do things that we regret. Our emotions sometimes govern our behavior. And then, a few minutes later, we say, I wish I hadn't done that, right? The AI system needs to understand that what we did that was driven by emotion isn't necessarily reflecting our true preferences about the future. There are questions about autonomy, which are quite difficult to understand theoretically, because autonomy means a preference to be free to do what we actually don't want to do. And it's quite hard in the context of decision theory and utility theory to actually work out how to value the freedom to do what you don't want to do. But it's important to retain that freedom. We do not want to be constrained to drive along the freeway of perfect futures. We want to have the option to leave that freeway should we so decide. But probably one of the most difficult issues with real humans is the fact that our preferences are plastic, meaning that they can be changed by external influences. And this has several consequences when you're trying to build AI systems that are designed to help humans satisfy their preferences. One is that since your preferences may change over time, if I'm an AI system, I'm acting that I'm going to bring about a change that comes true in the future. Should I respect the preferences of you in the present or you in the future? And I don't think there's a clear answer to that question. Philosophers have certainly considered it, but I don't think there's anything close to a consensus of how you answer that question. We also need to make sure that the AI systems themselves are not changing human preferences in a way that I think, for example, social media systems are. And finally, there's the question of whether we should take human preferences at face value. And you might think, well, of course, the AI system should respect human preferences and do whatever it is that human beings want them to do. But if human preferences are plastic, then they can be changed by indoctrination. And I think this is a real problem in all societies. We have to think about, where did people get their preferences from in the first place? And were they free in that process? And if they were not free in that process, if the preferences they have result from indoctrination for the purposes of other people, then do we want the AI systems to take those preferences, those indoctrinated preferences, at face value? I think this is a very difficult question, and I don't pretend to have an answer to it, but I think it's something that we need to think about. coming to the question of how we deal with many humans, well, one obvious thing, of course, with many humans, there are 8 billion of us nearly. The system will have to learn 8 billion preference models. That shouldn't be a problem. Facebook already has about 2.5 billion preference models for its members. And I think we may find in the process that actually there's a lot of commonality in how human beings rank potential futures, perhaps much more than one might be led to believe. But the difficult part about the fact that we all have preferences is that when you're making decisions that affect many people, you're going to have to trade off those preferences. Not everybody can be ruler of the universe. And so you have to make trade-offs when you're making those decisions. And of course, this is exactly what the social sciences, economics, moral philosophy, political theory have been grappling with for thousands of years. But we need solutions because we are implementing AI algorithms that make decisions that affect many people. So these are not purely philosophical problems. These are very real problems. And so philosophers, for example, bring up the question of how do you compare the preferences? How do you put preferences on the same scale in order to make those trade-offs? How do you know that one person's preferences are more strongly or less strongly felt than the preferences of another person? We have to deal with the fact that individuals have different beliefs, not just different preferences, but different beliefs about the world and about how the world is going to evolve in future. And this turns out to have very significant consequences. I'm not going to go into the technical results, but it means that adding up preferences actually is the wrong solution in a very strong sense. There's also the question of decisions that affect how many people exist. For example, China made a decision, the one-child policy, that deprived about 500 million people of existence. How do we weigh the preferences of those 500 million people who never existed against the preferences of the people who did exist? It's a very hard question. And if you've seen the Avengers movie, Thanos decides that if there were half as many people, the remaining people would be more than twice as happy. And so as a good, naive utilitarian, he executes his plan and gets rid of half the people in the universe. Now, you might say, okay, he made a big mistake. We do not want AI systems to be making this mistake. So we had better get these questions, the answer to these questions straight before AI systems have Thanos kind of power. And then there's questions about how we think about very important properties of human beings like altruism, sadism, pride, and envy. So let me briefly introduce some of those ideas in a very simple mathematical model. So once again, I apologize to those of you who are not fond of equations, but I promise they're going to be very, very simple. So the typical way that economists think about this is to talk about the utility of an individual as being composed of two parts. The self-regarding part, am I safe? Do I have enough to eat? Am I warm? Am I hungry? And the other regarding part, my preferences about my family members. I care that my family members are safe and warm. My neighbors, other people in my country, other people in other countries. So these are the other regarding preferences. They form a very large part, actually, of our utility functions. A simple way to express that is simply a linear combination. So in a world with two people, Alice and Bob, Alice's utility is Alice's well-being, that's the self-regarding part, plus some coefficient, the caring coefficient of Alice for Bob, times Bob's well-being. And likewise, Bob's utility is Bob's well-being plus some caring coefficient, Bob for Alice, times Alice's well-being. And so obviously, altruism means that the caring factor is positive. Indifference would mean that the caring factor is 0. And sadism would mean that the caring factor is negative, meaning that, for example, if CAB is negative, that means that Alice would give up some of her own well-being in order to hurt Bob. And you might say, well, that's pretty rare. But what do you do about it, right? Should the AI system factor in Alice's sadism into its calculations when it's making decisions on behalf of both Alice and Bob? And some argue no. So if the caring factor is negative, it should be ignored altogether. And John Hassani, who's a Nobel Prize-winning economist who wrote a lot about these basic kinds of questions, says no amount of goodwill to individual X can impose the moral obligation on me to help him in hurting a third person individual Y. And basically he argues that if you have negative caring factors, then you don't deserve to be in the collective calculation of human well-being. So that's something that we might argue is a reasonable step, a reasonable intrusion of moral theory into the AI system's calculations. But it turns out that sadism is much more widespread than you might think. And let me try to illustrate that. And it comes in the form of our preferences for relative well-being, or what economists call positional goods. So in other words, the happiness I derive from having a nice car consists of two parts. There's how nice my car is, and then there's how much nicer my car is than your car. And the second part is what we call the relative preference, or the positional goods. And it's a very important part of how humans conceive of themselves. So this is why we support, or we like to support, winning football teams, right? The actual visual benefit we derive from watching the football players run around is not that great and isn't that different when we win or lose, but winning gives us this feeling of relative well-being. So if we express that, if we extend our equations, then we have an envy coefficient, which depends on how much more well-being the other person has compared to Alice. And then the pride coefficient, which is how much more well-being we have compared to the other person. So envy and pride, if we rearrange this equation, we see that envy and pride are negative coefficients applied to the other person's well-being. In other words, they function exactly like sadism. But they're much more widespread than sadism. And so if we insist that our AI systems ignore these quantities, then that's going to have a much bigger impact on how they interact with society. And that's a much more difficult question. So to sum up, if you're interested in learning more about these thoughts, there's a non-technical book on the left, and then the fourth edition of the textbook on the right has more of the technical details of this new model for artificial intelligence and its properties. So to sum up then, I think AI has vast potential to be beneficial for us. And because of that, it has this unstoppable momentum, vast quantities of resources, many, many brilliant people are going into the field. But as our systems become more and more intelligent, we are more and more likely to lose control because those systems will be pursuing objectives that are not aligned with human benefit. And we have to avoid that. So in order to avoid that, I think we need a different definition of AI, which I call provably beneficial AI. I hope I've convinced you that it's possible and desirable. It's actually the kind of AI system we really always should have been building. And it's the kind of system people will want to have because it can gradually align itself with our preferences. So I don't want you to think that what I'm arguing is a sort of ethical argument, that I'm standing here saying, oh, all you AI researchers, you're bad, bad, bad people. That's not an effective way to go about changing behavior, right? The way we should change behavior is to convince people that, in fact, this is what we mean by high quality AI systems that are provably beneficial to human beings. And if we can do that, then all those AI researchers will get up in the morning and say, I'm just going to do some good AI today, and the outcomes will be good for all of us. Thank you.
I thank you, Professor Russell, for your very fascinating speech. We are enlightened a lot. So I would like to invite questions from the audience. If anyone of you have any question or in your mind regarding AI in general or the specific to this lecture, like the provable beneficial, the outcome from AI-related research, please raise your hand in the Zoom window, or you can post your question in the chat box. I think that will work. I think everyone is being muted other than me and few others. So I see Dr. Ahad has a question. So please, I think you are everyone can be unmuted, isn't it? I'm not sure about that.
Yeah.
Okay, so please, yes, please, Dr. Ahad.
Thank you very much. Thank you, Stuart Russell, for your fascinating talk and very, very insightful and philosophical indeed in another part. So my question is that in the new model you mentioned to achieve our objective. So now here by our, the point is that, the our is the business group, our is the army who controls the research and funding and so on. And their philosophies are basically not towards the mainstream of human being and the diversity, as you mentioned, and others. It's about war and even like sex toys and sex robots and these kind of things that, beyond the spectrum of human perceptions naturally and normally. So would you please give some kind of insight on this part, how to move forward or think to make some impact in the long run? Thank you.
Yeah, I think this is a very important question, and in some ways it's above my pay grade because it is really asking, do we need to restructure society at the same time? But I think, so what I'm really working towards is a technical approach that will be safe when we develop general purpose AI. And I think the advent of general purpose AI will have enormous consequences for the structure of our society. And I think we need to prepare for it in a number of ways. So one, I think, encouraging development is that most of the major technology corporations in the world have agreed that if they do develop general purpose AI, it will be shared and its benefits will be shared equally across all of humanity. So that's a very positive development. But that's a promise that's not entirely within their power to deliver on. They may be able to deliver the technology, but ensuring that it's going to be shared with everyone is a political problem. And I agree with you that it's extremely difficult. And at the moment, as you say, a lot of the developments in AI are actually being directed towards harmful ends. I'm pleased to say that the social media platforms have at least acknowledged that their technologies are very harmful, both to individuals and societies. And I think they have a genuine desire to change that. And we're in discussions with them to see about adopting this new technological approach. It turns out that this is a very difficult instance for provably beneficial AI because the systems are not only optimizing a wrong objective, but they're also modifying human preferences in the process. So I think it's important to understand that the people who have been polarized or radicalized by the technology, they're not sitting there saying, I'm really upset that you turned me into a neo-fascist, right? They like themselves. They like being neo-fascists. And that's the problem, right? So it's quite difficult to actually figure out exactly how to change the technology, and we are working on it. So I'm sorry I can't give you a more complete solution, but I think there are some positive signs coming out.
All right, thank you, Professor Russell. I have a last question because we will be starting a speech from the second lecture from the Professor Fukuda, but I have a question for you. Like sure. In life science research, I have seen that the researcher has to sign a document that the research will not harm the animal or any living being, and to get funding so that it could be beneficial. So if that approach can be introduced for the AI research, or do you think it is not a good idea to go to that direction at this moment, or it could be useful because the AI has very important consequences for the societies and the living being?
Yes, I think we're moving towards that. Medicine has had 4,000 or 5,000 years to develop its moral code, and AI has only had 50 years to develop a moral code. But I think it is happening very quickly right now. So, as I mentioned, the European Union is introducing very strong regulations, actually making it a criminal offense to produce certain kinds of AI systems. And that really is something that needs to be globalized. I believe the Council of Europe will adopt similar rules. And those Council of Europe treaties typically grow to 50, 60, 70 countries, sometimes even including Russia. And I know India is a member of the Global Partnership on AI. I'm not sure if Bangladesh is a member of that partnership, but that's an actual real intergovernmental organization with representatives of numerous countries that can recommend policies such as the one you described, a rigorous code of conduct for researchers. It's important to understand that we can't actually legislate specific kinds of AI unless they are technically feasible. So at the moment, people are discussing, should we legislate that all AI systems be capable of explaining their decisions? For many kinds of AI systems, that isn't possible. So if you pass such a rule, you would actually be banning entire classes of AI systems, including all the deep learning systems that exist. So the logical consequence is, if we want regulation, we have to develop the technologies to make it possible for people to comply with the legislation. And that's something we're working on.
Thank you, Professor Russell. I just conclude your lecture through a note from one of my very good friend, Mr. Fokruzaman. He has written a note in the chat box. It is a great pleasure and privilege to see and listen to a great AI pioneer and visionary, Professor Stuart Russell. I highly appreciate your great book on AI from my sporadic reading so far. So I think a appreciation from one of our participants today. So I thank you for your gracious presence in our conference, and we hope that we will get your attention and care from Bangladesh, and it will be great if you nominate or select some of our students from Bangladesh in your research group. That will be a great privilege for our country to work with you from Bangladeshi community. We thank you for you again. Bye.
Thank you very much for the invitation and the opportunity to speak.
Honorable Session Chair, I would like to draw your kind attention. If you allow me, I would like to take a virtual snapshot of all the attendees with the keynote speaker of this session. So I would like
yeah, that is fine. I don't know from my end, say from Session Chair, I can do that. I do not know. But
I will do that, sir.
Okay,
I would like to request all the participants to turn on their cameras if possible. Thank you. Okay, so I am taking the snapshots now. Okay, so lots of cameras are coming. I'm just waiting a few seconds. Okay, so 1, 2, 3. First one, I'm taking another snap. 1, 2, and 3. Thank you very much.
Thank you very much. Thank you, Russell. So our next speaker, Honorable legendary Professor Toshio Fukuda, he is here. So I request Professor Hafiz Abdul Rahman to start the session quickly. Thank you so much.
So I welcome Professor Toshio Fukuda. He has also very interesting topic, AI robots and moonshot program. I think robot is one of the important part of our life in nowadays, and especially in our country, we have also lots of worry like robot will kill our jobs and other things. But also it is fascinating to note like how the robots are advancing to become like pseudo-human. Like at the beginning of this year, Boston Dynamics posted a video, very short video, as a welcome message, New Year message, and we have seen the capability of the robots, how those have improved. I think that gives us a vision for tomorrow. And Professor Fukuda is being associated with a very important project in Japan, so he will be sharing this experience. So before getting into his lecture, I just would like to read of his brief biography. So let me go through that. Professor Toshio Fukuda is Professor Emeritus of Nagwa University and Professor of Meizo University and Waseda University. He is mainly engaged in research field of intelligent robotic system, micro and nano robotics, biorobotic system, and industry application in robotics and automation. He was president of IEEE Robotics and Automation Society from 1998 to 1999, and IEEE president just recently 2020. He was editor-in-chief of IEEE ASME Transaction Mechatronics 2000 to 2002. He was chairs of many conferences such as founding member of IEEE International Conference on Intelligent Robots and Systems, IEEE Conference on Cyborg and Bionic Systems, 2017, IEEE Conference on Intelligent and Safety of Robots. He has received many awards such as IEEE Robotics and Automation Pioneer Award 2004, IEEE Robotics and Automation Technical Field Award 2010. He has been a IEEE Fellow from 1995, SICE Fellow from 1995, JSME Fellow from 2002, RSJ Fellow from 2004, and VRSJ Fellow from 2011. It is really great privilege to get such a distinguished person, pioneer, foremost authority on robotics among us, and especially I'm very much glad to see a past IEEE president, because I have been with IEEE from 1991, almost 30 years. So it is a great privilege to invite him to this conference and to have the privilege to listen to his lecture. So I'm handing over the microphone to Professor Toshio Fukuda. Please. Thank you.
Good morning. Good morning, good afternoon, or good evening, where you are in the world. Rama-san, thank you very much for your nice introduction. Very, very kind introduction.
Thank you very much. I'm from Bangladesh. I'm a professor working in a Bangladesh university in Bangladesh. Thank you.
Hey, thank you. I'm very, very honored to be invited by Professor Ahad-san.
Okay.
He invited me,
Yeah.
along my friend.
He's a very good friend of mine, and he talks a lot about you and your achievements. So it's a great privilege for us.
Yes. So Ahad-san, my good friend, he invited me here in this important IC for IR 2021 in Bangladesh. Thank you very much. May I show my slide? May I share the slide?
Yes, sure.
Thank you.
Please go ahead.
So can you, Rama-san, can you see my slide?
Yes, we can see.
Great, that's great. Thank you very much. So I'm going to talk about a robot and moonshot program where I'm responsible for this kind of national project in Japan. Okay, so far I've worked on multi-scale robotics, such as things like many robots work together in many scales, micro, nano scale, others also many scale, many robots work together. That's the thing, like kind of monkey type of things, or some medical application, or many work together, or micro nano areas, they're working here. So these are multi-scale robot structures. So likewise, just a moment. Moment. I'd like to have a laser point. Moment, I want to see the laser. Oh, here, I can see here. Okay. So here, likewise, this is something like we were here. Here, cell makes a kind of organ makes a human makes kind of so many group of people, and then society of human beings. Likewise, about 40 years ago, I tried to make such a robot system based on such a modular robot. Then make a kind of cluster, make a robot, make a group of robots, and then many work together. It's called swarm robotics or collective intelligence, something like that. So I work with those here. Recently, I'm working also to again such a biological system and also such a kind of artificial robot system. So this is a non-organic system here. This is organic system here. I try to make it kind of combine them as such a bionic system, like kind of cyborg, something like that. So I try to make something like that today. So anyway, this is a kind of a micro nano areas. This is a kind of a centimeter, or many work together, something like that. So why is robotic automation or IT and robot technology very important? Is because in your daily life, you have this one, like you enjoy home security or education wise, also kind of environment, they can also rescue, or kind of tsunami earthquake, or plant or inspection, also kind of maintenance for industrial application, also the communication wise, also the intelligent transportation wise. You have many things here. Also health wise, kind of Da Vinci, also like a kind of surgery robot work here. Also the product wise, food, clothes, and housing, and also defense is also here. So what we are looking here, everyone want to have such a comfort space in any scale, like your scale, your family wise, your kind of classroom, or your kind of company wise, you would like to have a kind of good, efficient, comfortable space here, likewise. So that's here, like in hospital, and then there's somebody behind you also here. That's a kind of when you are sleeping here, so you need somebody here. Also in your office, outside, inside, there's somebody behind you. Also at home, or outside, inside, there is somebody here. That's called avatar robot. Also, when you're driving a car, you have such a kind of ITS, you have such a computing, because of communication. What we would say, the Robot 4.0 today, we have some AI robot, but what do we want to do? 5.0 to the 25, then Robot 6.0 to the 45. That's a kind we are looking for. That's a good, why 2045, because machine intelligence will exceed human intelligence, which was said by Krugman. So, but the AI people say that. But I don't know whether true or not in the robot community. Anyway, that's what we want to have, is such a kind of John here, like, and also like Betty-san get together, okay? But because of the corona pandemic, they cannot meet each other. direct in person. So then what you can do, then they can ask the robot to communicate for them. Robot A represent John, robot B represent Peterson. They communicate each other here, meeting physically or with these, or communicate or virtual online for them. Okay, they can have a good communication. On the other hand, A and B here, maybe there's a kind of big data, each, and also negotiator, A from A to B, B to A, something like that. They have a kind of thing. To do so, they need a kind of good representation for A sum, or also good representation for B sum, like a big data, and compare. They can negotiate those things. That's important to do so. Okay? So that to do so, you need a good AI intelligence or knowledge. So learning, adaptation, reasoning, recognition, consciousness, feeling, even feeling, right? Like a human feeling. Right? That's very important. So today, silicon technology, we have AI, CPU, software here, software, robot, okay, human robot. This is AI intelligence in the future, okay? BA, look at the biological intelligence here, human. We have a brain, we have great. We have our brain works less energy, unlike today's AI. So that we have our brain work here, human, okay? Eventually they can work together with AI and BA. As you know, today AI is supervised by the human. We mean the biological intelligence. So in the future, what we can do is like we can have such hybrid CI, combined AI, BI, okay? Computational intelligence, that's a thing. So what do we learn so far from this type of kind of learning here? So that's kind of like a big data, you can also fusion with meta knowledge, symbolic knowledge, intelligence. That's very important, but not yet clear. Also, we need a translational and additional learning to make sure our kind of knowledge, our kind of skill is kind of more adaptable or can be used widely with a loss of generality. Okay, so that's also linkage, linguistic knowledge, rules for conventional sector, because our rule, what kind of law was written by language. Okay, that's okay. So that's important, and we need such a good reasoning experience why that's a good solution is. Okay, also we need a real time. But so far, we were done. He said, well, it may be okay, but we use it all. The spectrum, as we say, I think intelligence is very important, but deep learning, diminishing, but the thing is, the AI, what we talk about such a 2045, we want super human intelligence anytime soon. That's Ronnie Brooks, our friend, says that. So anyway, many people ask me, Toshi, what's the next intelligent robot? Well, in the robot, maybe we can find some kind of smart speakers here from Amazon, like Alexa, and adding such a my robot like here, such a kind of a brachiation robot here. Mobility device. Also, you can add a human interface like this for my logo, so they can combine both of them. So that AI, Amazon speaker will play important role to combine those things, such a kind of mobility and also such a kind of interface. So today, actually, they did it. When they make it a real one here. Yeah, that's a robot by Amazon. That's Astro. So that's nice. Yeah.
A robot. Yes. What are we going to do with a robot? Well,
So that's kind of Baba. But this is not new, okay? This type of robot already existed 15 or 20 years ago. Okay? But those days, the lack of just kind of good AI. That's the thing, okay? So today, there's a appear using can say like a smart speaker, like that technology. So what you can say AI, robot, and Internet of everything, or Internet tech thing, okay? Internet thing here. So they can collect all data by sensors, and AI analyze what it will be, what's the solution, or what's the optimal. Then the robot will react to the outside as a muscle or actuation, okay? This is the kind of thing here. So today we can find many scenarios for the future. Maybe connection human machine, as you are doing now, or expand the activity space of human race, what we have done, like automobile manufacturing, whatever it is, or respond to new risk here, extension of human capability, or even human alternative, like that. Okay? So when you look at such a mega trend today we are facing in the world, is such a global warming, say temperature going up 1.5 degree by the end of this year, this century, aging problem now kind of many society is now getting older, more means or Asian people is more than younger people. Okay. Also, we are not prepared to have as good enough food and water here. Also, urbanization. Many people go to the big city. Okay, like that. Why so? Because they attract young people. But also, it's not nice. More distribution here. Also, energy here. Energy is important in conjunction with global warming here. Such a kind of energy. We are now looking for sustainable energy here. Okay? To do so, what robot AI can do that? That's a question. Okay? So a pyramid, okay? Also global warming here. So look at that here. Okay? Now we're here, and the 2010 to the end of this century, getting more warmer. And what we can do by robot technology is that we can work for GHG, greenhouse gas issues. So that's a kind of thing, carbon neutral, or kind of energy planning, okay? That's important. So that's a kind of, we should work on GHG, greenhouse gas-oriented robotic automation, okay? Like global warming, and carbon neutral, on sources here, also like that. Of course, we are doing 3R, reduce, reuse, recycle in robot automation, but it's not enough. Now we are asking EV, electric vehicle, electrification, control method, and smart mechanisms, and to make it to challenge such a mega trend. Or bio application, the biostimulant, that's great because biosystem is a very energy friendly. It works by far less energy level. And smart sensor system. And then later on, I can talk with moonshot program. Why is so? We need those things here for those things. So you can see such a great global warming threat. You know that. So you hear that here, weather devices, or can tropical storm, or food shortage, or can sea level, also like kind of malaria infection or extinction, some extinct like that. The history, our society back to 1,000 years back, whenever we have such kind of extraordinary weather, there always some kind of a disease happen, like such a kind of pandemic, corona pandemic, one of them here. So that's important to think about. And then when we talk about GHG in the greenhouse gas thing, is always here that recycling or kind of low or GHG agriculture or construction, those and also energy conservation like that. Why I put up such a kind of agriculture? Agriculture is responsible for the such a generation of carbon dioxide on globe, more than 20-25%. That's important. So also kind of construction also they use a lot of energy. Okay, that's why. So we should work on such a kind of more sustainable way to make the society survive. Or like look at that here, agriculture. Agriculture that we are field maintenance, weeding, also improvement. Also we need a kind of diversity here. Also food distribution and all lots of food. Today, such a kind of 1/3 of food became a food loss, go to the garbage. That's why it's very important to think about those can see here. Also like kind of construction-wise, the construction, usual construction, they don't care, they can make it, many things here. But today we have to think about such a kind of design, high efficient work, energy conservation, and recycling, and sustainability. That's important to this. So also don't forget it. Say intelligence safety issues is very important. So look at here. That's very nice to have a mobile self-driving car, but once it happens, something can accident happen. That's a tremendous bad disaster here. So need something. Also, I tried to mention about kind of bionic system. As I mentioned, like a cyber, like that. This comes from robot here, and also here, like an AI creature-wise. Why they can behave so well? That's nice. And here, first of all, we have such kind of computation, communication, then we can have such kind of enhanced sensing and launch or many things here. Sensor. So also here, we need a kind of sound sensor here, need a kind of energy source and agricultural, artificial kind of organs here. So also the kind of protection system here, on the muscle here, like this. Then we need this kind of neural interface. So to do so, we need to have a certain individual level, bio level, or group level, device level, or system level here. That's important to think about. Okay? That is so like kind of alternative device. In my case, I lost my teeth. I replaced with artificial teeth. Then it's a kind of bionic system, alternatively. Also, many others. Some people have kind of artificial ear, or some people lose such kind of some part, like kind of artificial lung here. So they can use such a kind of artificial lung for 5 to 10 years. Okay, then they can replace it with a new one like that. Even like Olympic game, such a kind of Paralympic here, then they always have a nice kind of devices here. Anyway, when you talk about kind of cyber, you just you might imagine cyber is just something to put into such a kind of failed path or a lack of something. Then we can add something more. No, not only that. If we want, you need a kind of if you are so busy, you need a kind of something like more kind of a hand, more people help. So that I can see here, like a super limb here. So they can use those kind of limb as you like. So likewise, intelligent manufacturing system, IMS. That's again very popular. I work all those things here. And here, nice. 2 robot, small coordinate together to carry heavy payload, or something happened, they replace it here, re-challenge, rephrase, those things here. Also like a construction-wise. Construction here, maybe construct here, but they need such a good behavior. Back here, not only such a kind of a thing, we need a good kind of such a kind of control system here. So when you look at the hierarchical self-organizing system here, what we are mentioning, many like organ, make an individual make a society. Likewise, such a kind of self-organizing global system requires flexible structure, open system, and multi-agencies here. Hey, look at here, this kind of picture. Okay. Anyway, this is a kind of a many robot, display robot. They can move around, but they have to be really smart to keep the distance between the robot within 20 meters. Otherwise, they lose the kind of communication. Once they lose the communications, you cannot use the internet. Then what happens? You have to stop your research work or development here. Also, like a concept self-organizing product system here, input inside here, there are many kind of working here and making those things and going out like that. That's important, such a self-organizing product you can do as you like. Okay, so like I made this whole thing here, just for example. We work together with the Bosch company and the other company, and also in Japan, also Germany. Yeah. So that's nice. This is a kind of way they can decide how to do. So we can cover those things here. So in case something wrong, they can supervise, just make another plan.
Such a system should also be able to respond autonomously to the manufacturing environment.
Okay. Yes. Then like application mean that's a robot. Here the robot here, moving here, they each have a same algorithm and they can work together. Okay. Good example is Amazon. Amazon is here. Usually, when you have a kind of a big warehouse, you have to go around, pick up what the other people, consumer want.
They are strong.
That's important.
And the color of order crush. These machines were created by Kiva Systems, a Boston area startup that wants to reinvent the warehouse business using robots. Lots of robots. Kiva's idea is simple. By making inventory items move instead of the workers, they can fulfill orders faster. In Woburn, Massachusetts, Kiva set up a warehouse to demonstrate the system.
So I submit that order in. It understands that
Kiva system is good, so they are bought by Amazon.com. So it's a very human friendly. She doesn't go around with a big warehouse walking from corner to corner, but she waits, those things coming, and she pick up what she wants. Anyway, now based on such experience by myself, we launched such a kind of moonshot program a year ago. The moonshot program, the Ribbon program, set ambitious goal to attract people and promote challenges around the project with the aim of resolving difficult societal issues while bringing together the wisdom of researchers from all over the world. That's a kind of thing. So do that. So budget-wise here is kind of about 120 million US dollars for 5 years.
Professor Fukuda.
Yeah.
Fukuda Sensei, I mean, I'm not sure. Your slide is stuck on the concept of self-organizing production system.
Oh.
I think you already crossed this slide or still in the same slide?
No, I'm moving to another slide.
Yes, because from your speech and the slide, I found that the slide we can see is the, concept of self-organizing production system. So maybe if you just check, because slide is not moving in the Zoom.
No, not moving here.
Yeah, I
Can
think
you see the moonshot program? No.
I think
No,
hanging
not
here.
yet. So that's
Not
why
yet.
not yet.
It hangs.
Like a kind of moonshot. This is a kind of mountain, Fuji.
Yes, Professor Fukuda, yes, it has been stuck on this. If you can see the Zoom link, it is a factory floor. It has been showing. We haven't seen any other slide following that.
Really? Ah, that's good. That's so nice. Maybe a moment. Oh, tell me that. Not this one, not yet. Let's see. Let's
We are
see.
not seeing anything new.
New? Bad. You tell me more. Once again, then once again, I just make such kind of a. I stopped the sharing the slide, okay? First.
Yes, Sensei, yeah.
Then
So
again,
the slide and start
then
from the
started.
page.
Over here.
Yeah, we can
Yes,
see.
good.
So now I start from this slide 73.
Just a kind note to Professor Fukuda that I will be leaving at 12:10, and following that, Dr. Ahad will continue this session as the session chair. Is that okay, Dr. Atik Ahad?
Yes, no problem. No problem.
Okay, so I will be leaving at 12:10, and following that, you will preside the session.
Okay.
Continue with Dr.
Hey,
Fukuda.
yeah,
So,
wait.
Professor Fukuda, you take as much time as you want, because our next session is 1 o'clock. That is almost 1 hour.
Okay.
So you have plenty of time.
Okay. Many, can you see my slide or not?
Yes, Sensei. Moonshot slide, $120 million. Yeah, we can see. Yeah,
how about this one?
Sensei. Yes, perfect. This is we choose to go to the moon with Ahad.
Yes. Yes. Okay.
Yes, Sensei.
So, John F. Kennedy, he made such a kind of a plan in 1960. Likewise, we decided to make such a moonshot research development program that's kind of by Japan government, and that we can make such an ambitious goal to attract the people and promote challenging R&D project with the aim of resolving difficult societal issues while bringing together wisdom of researchers for all the world. So many people can join. Anyway, this is a moonshot program. Can you see the slide? Hey, Raman-san, can you see my slide?
Yes, we can. Yes, we can see
Okay,
your
great.
slide. Yes.
That's great. So moonshot program here, it's a kind of AI robot. It's a kind of work 120 million US dollar wise for 5 years, and we are having more. So more. This budget will be double next year. Anyway, this moonshot go is I'm responsible. This one AI and robot. The goal is this moment. Okay, goal is by 2050, a robot can autonomously adapt to the environment, evolve itself, intelligent, and act with a human being. Of course, that we aim to 2050, like that. Then what we can do, we can think about, we can backcasting such a technology from 2050 to 2040, then 2040 to 2030, then 2030 to 2025. That's the kind of we are doing so far. So technology, you can have such a goal human, step by like that. But we just going backward from 2050 to 2040, 2030, 2025. That's a kind of moonshot program here. We are not such a kind of step step going up there. Instead, goal is set up in such a kind of backward. Okay, so that's here. So we have a three type of thing in mind. That by 2050, that the development AI robot, that human do not feel uncomfortable, have physical ability equivalent to or better than human, and grow with human life. That's a kind of one. Another type two is by 2050, the development of automated AI robot systems that aim to discover principle and solution by thinking and acting in the field of natural science. Means a kind of a robot scientists work together with the human research scientists. They can propose some kind of hypothesis, work together, make a kind of experiment, those things that then they can reduce such a search space and look for something better. Many research work going on to find the kind of medical drugs here or good material and so forth. We can go into more in detail by robot, AI robot. Also 2050, develop the AI robot that autonomously judge and act in environment where it is difficult for human to act. So that's again here, so if there's a disaster by typhoon, for example, we can send a robot, okay, instead of human, because it's dangerous in such a kind of environment. Or we can send a kind of robot to the moon or some other planetary areas, planet, then we can explore such a here for in the future, 2050, maybe people live there, particularly on the moon, for example. So that's here. So this is a kind of, maybe I made it a kind of Fuji Mountain, Japan here. Maybe we are aiming at next AI technology, next robot technology here, and try to make such a kind of fusion AI, co-design, co-evolution, co-sensation, co-partner like that. So like here, physical interaction, information interaction, very important between human and robot, like that. So that's an embodiment, okay? So maybe this AI area, AI robot technology here, such as self and compromise here, like that, or also robot-wise embodiment, and also kind of sensor for tolerant material, motion-wise, task-wise, actuation-wise, mobility-wise. That's how we try to make the next kind of technology. Everything under such a kind of LC issues. LC means ethical, legal, and societal social implication. And also, standardization is very important for many people in the world to share such a knowledge, okay? So once something happens here, like a spin-off, spin-out, that's a kind of welcome. So target one is that's here. How we can do that? Okay, this is kind of here, treatment, nursing, or business-wise. That's a kind of one robot can do that. Second one is such a like here, image and emergency here, the field robot, and natural disaster here. So they can here work together, like here, okay? Many robots work this. That's a group robotic technology. That's a kind of AI, that's important to do so. That drone checking here like that, and making something like that. So once, for example, this river here, flow. River flow is a kind of stopped by such a kind of disasters, then the road come here, try to have a kind of hose here, they try to remove those things, but first of all, they need a kind of water pumping here to here. But this is dangerous, so robot can do autonomously by many robots. Of course, you can use such a kind of teleoperation at the beginning, but eventually we try to make it to such autonomous kind of development by 2050. So look at here. This is a robot at the volcano site 1992, back almost 20 years ago. So maybe here, many this widespread volcanoes, many these are all teleoperated. We replace those teleoperated with an autonomous one. The project 3, the vision, day of scientists. Okay, so that's here, day here. Okay, that's a nice people work together with a robot, make it. So co-evolution of human AI robot, providing everybody can be a scientist with this robot. Find such a nice kind of a solution, so nice finding discovery, something like that. That's a good work together. So the robot had to read many kind of literatures, abstracted, give such a, so that the human cannot read everything. Okay, that's here. Also, like kind of human can give a question, maybe like a special one here about this like that, and they can make a hypothesis together. That's important to do so. So this is the ones here, a robot, a scientist here, and here, hypothesis here, design, action, observation, analysis. So then go back. This cycle is very important to do so. Make a hypothesis here, design, they'll make it, okay? So they can have a kind of good work together, working human and robot with such a good AI. So this is evolution of AI robot. First of all, is a vision society to the future. While we are aiming at such an age society or something like that, neither such as here. Robot will be everywhere in our daily life in the year 2050. And we also all using them natural way, okay? So our goal is to develop a robot that can provide appropriate support and services depending on where they are used and on the condition of the user. Okay, this is very important. Well, some people, young people need something like that. Young one need this one. Young one or other people need this one, and young and the baby need small kid needs something like that. This is the case here. Okay, then this is something like here. We are looking at such a robot who can improve such a self-efficacy. Let's help people work more with their successful experience. We help them just a little bit, not 100%. We just have 10%, 20%, something like that. Try to let them stand up by themselves. Okay? So maybe they can do that, then the robot will try to make a kind of something like that. Try to find such an experience, successful experience, then add something like that, and then we can assist here. Then he or she thinks, maybe I can do it by myself. That a robot kind of initiation here help with everyone do that like that. So that's a challenge. They can do that. So this is a self-efficacy that we need a kind of good modeling, good thing, and we are looking for such a kind of good kind of suggestion and those things from you. We work together internationally here. Okay, that's it. So that's a kind of sustainable development goal. Is the SDG sustainable goal. That's important by United Nations, stipulated 2015. So look at such a 1 to 17 goals, SDGs here, 17th, then 7 or 8 items here is relating to AI robot. That's here. That's all I put here. So that's very important. So you in the Bangladeshi people here, or other people here for the world, Japan-wise, or European people there, American people there, Asian people work together. Don't leave anybody behind. That's important to this. That's a robot can do that. And we are aiming to the 50. That's nobody left there. So, okay, that's the kind of thing here. And we are aiming those things. And we are welcoming your kind of devices here. Okay? That's good. So, as I said, kind of Isaac Newton, Sir Isaac Newton, our kind of big kind of respected person, made such a good comment. No great discovery was ever made without bold guess. Also, he mentioned to the letter to the kind of Robert Fuchs here, if I have seen further than others, it is by standing on the shoulder of the giants. That's our ancestor, our kind of senior people did a good job. We are based on their contribution, what they have done. We can advance furthermore a little bit. But still, it's important to think about it. And that's the kind of thing. And sorry, at the beginning, I didn't notice that I have a kind of a slight problem. Thank you very much. Ahad-san and Rama-san pointed out. Oh, my slide didn't work well. But anyway, what I want to say is such a kind of things, based on some many things here. But today, I was so happy to show such a kind of our good kind of big project for next 5 years. So totaling about say almost US dollar wise. Next year we're adding more extra US dollar wise, 250 US dollar, 250 million US dollar. Okay, that's kind of for 5 years. So that's a kind of things. And I'm looking for many suggestions from or advices from you. Going to start more and more. And some of you, if you're interested, come over to Japan. We can welcome you, other people, to do so, like AI and the robot. That's something. Summary wise, innovation challenge. I mentioned about 5.5, 4.0, 5.0, 6.0. About 4.0, that's a regular robots today. Robot 5.0 is a right kind of to the 50 or to the 30. That's a kind of robot. And robot 6.0, that's a kind of thing. The year of to the 45. As I mentioned, to the 5 is a kind of well, it was proposed by Kuhlman that machine intelligence will exceed the human intelligence, he said. But I don't think so. We can work more about that. The human is very smart enough to do so. That's important. Also, aware robot, awareness of, it's important. That's a robot with awareness AI. That's important to do so. That's a kind of a sympathy type of kind of thing. Not only kind of sympathy, but we need to kind of think about other people. Empathy instead of sympathy. Okay, that's important to do so. Also, human-centered robot system with AI and through integration of human activity and the loop and the safety and intelligence. As I said, important to do so. And ethical design, autonomous system, very important. Okay? That's also technology development, the public acceptance. We always face on such a kind of robot system which was not accepted by public so far. But we need such a kind of public acceptance from the beginning. And this must be transformative research, because we saw that the moonshot problem. Moonshot is not a regular type of thing, research work, but we need a kind of good transformative and type of non-linear type of kind of jump of research development. And also, thank you very much. Sustainable development is important. So that's it. So thank you very much for your attention. Thank you very much. Today, I just give us some talk, even though something happened and the problem, but I have to talk about it. Thank you very much for your attention.
Thank you. Thank you very much, Fukuda Sensei. It's a great pleasure for us to listen from a giant like you. As you mentioned in the slide that Newton said, that shoulders of giants, and actually you are one of the giants. We are proud of you. And I mean, for the audience, we don't. I mean, you may know that. I mean, he is not only a legendary academic researcher and leader. I mean, at the same time, he has more than 100 PhD students. He gave more than 100 PhD students an amazing work so far, and he is a wonderful and very humble person. I am very proud of. That he's here with us today. So now the floor is open for questions and answers. So if you have any questions, so please feel free to raise your hand and ask. Otherwise, you can type on the chat box. And I request that those who are in Facebook or YouTube Live, please just share the questions in the chat box. So,
Professor Rahat, I have a question.
Yes, great.
Okay. In your conclusion slide, you mentioned about the singularity.
Oh, singularity, yes.
Achieving the singularity by 2045.
Yes.
So are you aware about the convergent? Do you see the relationship between, number one question, relationship between convergent and the singularity? And what is your basis that we will achieve singularity by the year 2045?
Oh, so I didn't say that. The AI people, like Krugman, they are talking about such an AI. The AI people think, well, they think the AI is very good. That's why they propose. They said their AI will exceed the intelligence of human being as in the year of 2045, they said. But we, like Lonnie Brooks and I, we're a little bit doubted, because human is very intelligent, okay? That just, you know, in about 25 years, do you believe they said the machine intelligence will exceed human intelligence? I'm not sure. That's what I'm saying, okay? People think people can say that. However, there's no such a kind of reasonable thing. Human being is very so smart, so that they can prepare those things. They study more higher than the before. So that's a kind of my kind of interpretation. Even they said to the 45 singularity. No. That's why machine intelligence will be much more than beyond the human intelligence. They said, but maybe some part, but not all the things. Yes. And
thank you very much. Any other questions from the audience? Okay, so let's wait for from others to ask. So sure. I have a question. This is about the evolution of AI robot, the adaptable AI robot, that part in one of the slides. So my point is that, say, like emotional or psychological issues in robotics are still beyond the, I mean, human perception, like a human being's ability and the robots' emotional or psychological development to deal with human. The progress is not so much. How do you think about that? Because if we say that robots will overcome, I mean, take a huge lead in the next 20, 30 years, then emotional and psychological issues and the empathy and, of course, legal and ethical issues are also important for a robot or group of robots to understand. So these are very much challenging. But any comment on that, please? Thank
you. In my slide, I mentioned by such a kind of asymmetry between human and robot. If I say it's a symmetry between human and robot capability, means robot and human is almost same kind of level, okay? We can do that. Unfortunately, today, such a kind of robot human is not such a equal in a capability. Kind of recognizing such a kind of a feeling. In this case, human is better than robot, but the robot can remember also what happened so far, la 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 la. So this is not a symmetric, okay, in the behavior wise, function wise. So that's a kind of thing here. So the feeling wise, for example, what you mentioned, okay, your question. That's like a robot today cannot understand such a kind of human feeling so well. But the single human can understand what other people do that. So that we try to have a more kind of intelligent way, such a robot can understand and such a human behavior, but also human feeling, and try to have a more kind of empathy. That's the thing. That's a kind of, so the robot, you know, that's a kind of thing, okay? It's not symmetric. So that's why robot, human can understand what the robot doing, robot cannot understand. But the robot can do more than like that. Of course, robot can show such a kind of expression of kind of sad, or happy, or surprised, or that's it. But that is not enough. We need a more generic, more such a kind of engine of feeling. That's a kind of AI. So we try to develop such a kind of engine for or AI for kind of feeling. Yes, that's a kind of very important. And this is a kind of kind of we have to work together with psychological scientists. And one of them, that's as I mentioned, is kind of self-efficacy. That's the thing. So we don't support the people 100%. No. We just give 10%, 20% more. We don't do too much. Okay? This is such an intelligent way to do so. Understanding such a feeling of those things. Okay? Thank you.
Yes, thank you. Thank you very much. Any other questions or comments? If you allow me, Professor Fukuda, sure. Is it okay to ask a few more questions if you have?
Sure, why not?
Okay, wonderful. Thank you. And another point is that, I mean, just today, Matthew Turk had a presentation. He discussed about the fairness and bias, racial bias or other kinds of bias, these kind of biasing issues. Now, if a project is solely done in Japan or in China or Korea, where diversity or multiculturalism less, so those concepts or robots and their, I mean, AI part will be basically for that kind of people and for that region mostly. Am I right?
Yes.
It will not be universal, and it's very difficult to make it generalized. I mean,
that's
AI
a problem. That today, this is where we are very concerned about those things. That's a kind of a vulnerability of AI. How we can avoid such a kind of bias on here. human is educated from the beginning. Okay, it took 80 years or 10 years or 20 years to get a degree, first degree. Okay, after the education. But robot-wise, they're not easy for them to teach, educate. How we can do that? Generically, they are such a kind of humane, okay? That's very important to do so. So we did such a mechanism to have a kind of to avoid such a biased behavior. Okay? So we need such a we like we are educated in a way. We are what's fair, what's kind of unbiased here like that. But robot, in this case, what we can do that? This is another issue to have those things. So that's why we are talking about LC problem, LC, ethical, legal, social implication for the beginning. So that's kind of working together. That's important to think so. Particularly what you say, the diversity, inclusion, like that. But that's a kind of thing. But anyway, such a kind of bias one, kind of fairness. That's a kind of very important you mentioned from the people end of LC. Thank you.
Thank you very much. Any other questions? I didn't find any raised hands. So I think that we have taken plenty of your time, and we are really grateful to have you. And hopefully by the end of this year, I will try to meet you again.
My good friend. We should get together.
Yeah. And then we discuss some of the issues regarding this project and whether I can be part of it with some others globally, and especially with some great researchers from Bangladesh and our students. Yeah. So thank you, Professor Fukuda.
Thank you very much for your invitation.
Yeah, and hope to see you in Bangladesh in the future, and of course in person in Japan. Yeah. See you. Sayonara.
Sure, bye.
Thank you so much.
Thank you.
Bye-bye.
Bye-bye.
Dear Ahad Sensei, if you allow, we can take a virtual group photo.
Oh, okay, okay.
With
Please,
our
please
keynote
take a photo.
speaker. So I would like to once again request.
We'll take a photo together. So.
Okay. Can you see my face?
Yes, yes.
Okay.
So I would like to request Fukuda Sensei to stop the presentation, please.
Okay, so a moment. Okay.
Okay.
Good.